So good.
It's not time yet.
Beast has a blink now. When I get shard, we can probably just hold them even when they have Aegis.
I'm not ready. Not yet. Gold and sweet.
I have shard, we have glyph. If they want to push us, we should fight.
Your top tower is under attack.
Yeah, I'm gonna pour it.
Double. Dire structures are fortified.
Yes. I'm not ready.
No, no, we can really. No, we
Beast
no,
has
we
blink.
can't really.
Beast has
Good fight, it's okay.
Yes.
Oh, I actually went.
No ulti, no ulti, no ulti.
I'm just gonna do this, get rid of the stack, so I was getting out.
Fiercely now. Not yet. Yes. Let them see
That
our
was good.
teeth. I'm not ready. I'm not ready.
Alright, easy. Great, this game's pretty easy.
On notice.
I mean, our draft is pretty good. I've been lucky today. A lot of the drafts that we've had have been pretty good.
Time yet.
Actually, is that true? I had a Tusk mid in one of those games. I mean, it was Moose Chad, so like, it doesn't really matter. He probably could have picked like, I don't know, CM mid in one.
Yeah, go.
Right. It's not time yet. Your blood is mine.
Could be a bit 3-2-2. Oh,
It's
this is
not
definitely.
time yet. Not yet. Join me.
They use roar.
Go to. Not yet. Interloper. Enough. Push them back. Another slotted down.
Like, I don't know, Mason's actually really,
Could have
really
had your
good.
waist
Like,
back.
like not tier
Oh,
2 good,
what can you
but,
do,
like,
bros?
really
What can you do, Mason? I'll go BKB. Play it safe.
good. Like, yeah, Mason's actually super solid player.
Actually, Satanic is quite good this game. Do I even need BKB? I mean, it's only good for roll. Satanic's insane this game. Dispelling the Orchid, dispelling I mean, BKB is insane for the same reason though.
You don't get like the stats resist though. Does that still work?
Carried by Lucas. I mean, I'll give credit where credit was due. Lucas didn't shoot his
Doesn't Hag
pants
still
for once.
purge
Like, I'm proud of the kid.
Huh?
Like I'm
I
his,
guess
I'm basically his
that's
father,
okay,
right?
man,
Like
but
I
still.
invented him. Like without me, Lukey would be sitting at 20 viewers right now. So, yeah, I'm proud of my son. Did pretty well this game.
Holy fuck, what the fuck? A Dire comeback? Dire is like 33 kills
Why are you guys
ahead.
crapping? Dude, when Lukey was streaming for like months and months and months. I randomly hosted him one day. He was a 100 viewer streamer. For months, 100
I actually
viewers.
don't-
I hosted
I
him.
don't know, like, I wouldn't put
I,
Radiant
talked
out,
about it on my stream,
actually.
and all of a
I
sudden
think-
this guy blew up.
I mean,
Like,
Dire's
like,
ahead for sure, but their
I
high
don't
ground
know
kind of
if he owes
sucks
me
ass.
royalties or anything like that. We don't need to go crazy, but like maybe some form of compensation would be appreciated.
Set upon them.
Like, literally, Ursa is like tanky for sure, but like, his ability to hit high ground is almost predicated on how far ahead he is. Because like, if your Ursa has only like 2 items, and he starts hitting your high ground, it feels like shit. So the only way you act, because you don't naturally have like damage to hit towers, you just have damage to hit heroes. But I mean, it's not like, I'm not saying he's terrible at doing it. Yeah, dude, Ursa Battlefield has been a thing for a while. I mean, I'm not saying Ursa's like terrible at hitting towers. I'm just saying that he's probably not the most ideal. But I mean, 24 HP regen per second is still really, really good though. So, who am I to complain?
For the forest.
Plus, the people behind him are all magic damage, so he's got to like run in against like what? Roar, Beastmaster Roar, Pango Roll, all this fucking spells, dude. Hey, what up, man? I'm not actually playing, by the way. We're just like chilling for like 20 minutes, just hanging out until we actually get started with our shit. So, if you're new to the stream, hello. My name's Edward. I was actually I'm a software engineer. I currently coach people on how to get jobs in tech and to consistently beat the coding interview. Prior to this, I was an engineer at Apple. Currently I'm an engineer at Uber. So what's up, y'all?
When is Roche? 27? Oh, 24. Oh wait, it can spawn. That's what that means, right? 20.
Who calls me?
Yeah, right now we're just watching Mason stream. So if you guys have any questions about like tech, the software engineering industry, maybe a little bit about me and my story, I'll be happy to answer them. You know, provided they're not covered by NDA.
I'm just running around
Where
in circles.
you should sell a discounted package where you play Dota while
Roche, like,
coaching.
spawned literally right now, 27.
I mean, here's the thing. When I watch people who code, it's like I need to watch every moment.
I feel like
And the
these
reason
timers
why
are
is
right.
because everyone's thinking is like everyone thinks different, but it's all still very logical. So for instance, like let's say you skip out on planning, if you miss out on planning, then you miss out on coding, you miss out on coding, then you know, then that's where it all falls apart. Now, someone who isn't like totally familiar with what it takes to succeed is going to say, "Oh yeah, you messed up on code." When the fact of the matter is that you fucked up way beyond that. And that's kind of like why I am hired. I'm like the guy you ask when you literally cannot figure out why you're fucking up. And I will literally watch every single moment you do. I'll say, okay, this is why you failed to even set up 60% of your problem. Here is the problem with your thinking, etc., etc. You know, so it's not something I can just like, you know, go play Dota and look back at some guy and say, oh yeah, this is, you did this. You know, it's a whole process.
A loss so small, the world will hardly know.
He does a good job as a repeat customer. I mean, yeah, it's like every single time you show up, I'm going to tell you what you're doing wrong, you know, and how to fix it. It's ultimately up to you whether or not you fix it, and I find that for most people, if they do like 2 sessions, they're almost like guaranteed to pretty much succeed, like in an interview. I think my going rate right now is that for people who get, like across every single interview that people do, for internships, jobs, whatever, I have like 70-75% rate of passing for my students. If you change it to people who get at least 1 job, then that shoots up to like 80%. So I think that speaks a lot to the efficacy of what I do. I think most people who do succeed are the ones who get like 2 sessions, and then like beyond that is like diminishing returns for sure. Because usually at the point you need to hire me, you already have the basics down. You already are familiar with like what heaps are, how to sort a list, a binary search, etc., etc. The only question is execution, and that part is mostly a result of, you know, thinking the right way. And if you do it right, you don't actually need to think that hard. Like one of the things I really preach is that it does not really take a shit ton of money or time. It just takes good effort concentrated in the right areas. So, you know, you can go out and pay like $1,000 for a coding interview camp, or, you know, like or you can just like watch my videos, to be honest. I think I offer pretty much the exact same shit.
I'm really gonna push myself. Trust me, guys. You want to be there for this one.
Would you suggest someone to postpone graduation if they get an internship?
Maybe even to cap it off at the end of the night, Taro?
See, here's the thing. That's a little bit of a hard question. It depends on where the internship is at and what kind of work you're doing. Keep in mind, the point of an internship is to see whether or not you like the company, you like the work, and you want to go there, you know? So, really, if you're delaying the graduation just to keep working an internship, I think that's a little bit of a waste. Only because, like, well, why do you have to keep continuing the internship? Why can't you just do it for the summer, go back to school, and finish that up? You know, any more than that, then they're seriously starting to underpay you. Like, the longer you're on the project, the more valuable you are. And so, if you are, like, 6 months, 9 months into a fucking internship... Oh, it looks like Mason stopped the stream. If you're 6 months, 9 months into an internship, at that point, is it really an internship? It's not really. You're pretty much working like as a full-time employee, especially if you need to take off school to do it, and they're paying you like basically kid wages for that. Doesn't make much sense to me. It feels like it's just a way of ripping you off. As long as you get like your 3-4 months in, you're fine. I mean, don't get me wrong. The way I came up was by doing contract work and basically working below minimum wage. But it was fully understood that that wasn't an internship. That was basically a full-time opportunity and it was for a startup product that didn't have like a customer base. So instead, I actually got paid in equity.
No.
Yeah, I think I did a video on this, but yeah, that company's worth now $300 million, and I got like I think 0.1 or 0.2% of that. So you know, you do the math.
Motherfucker.
It's a nice chunk of change for doing it as like a contract work job.
Hello, Burba?
Oh,
Calm down, okay?
Best of luck in DPC, mate.
What the fuck? Who killed me?
okay. This Leshrac should. Is there a Leshrac in this game? Okay,
Oh,
yeah.
no!
This Leshrac kind of is gonna get owned.
No ages, guys. No ages. No ages.
I don't like playing Windrunner into Leshrac or Leshrac into Windrunner. It's just that
Dang,
whoever
good
catches who
for
first
some
is the person who dies. You know.
Non-locker maximum.
But I think overall, ooh, nice. Yeah, I think overall, like this is pretty clear as Dire favored. Like this Ursa just, the only person this Ursa can really go on is the Timbersaw. That's it. And even then, Timbersaw just like runs the fuck away. This Ursa just cannot kill. I don't think this Ursa kills anything. Like Windrunner just runs the fuck away. Lifestealer moves like 450 move speed or some shit, and he always escapes with Infest.
Oh, people
Windrunner
DPS.
just
I can't
no,
cancel
Timbersaw just
They have
runs away
blink.
too, and Earthshaker
Oh,
just
they
kind of
have
like
blink
blocks the
on
terrain, so
Lash,
Ursa
right?
can't
They
really
have blink
chase.
on
It's not
Lash.
really a game.
I'm literally gonna kill the both supports.
Yeah, Lifestealer and Beastmaster are hella busted.
I'm gonna start jumping.
All right, let me start gathering some people and getting ready for everything. So give me a sec, guys.
Oh wait!
Let's see what's
I
on
just
Hacker News.
realized.
I'm actually
yeah,
really curious.
Nick's gonna cancel me. Fuck, you guys are right. Ah.
I might as well bring this up while I'm waiting. Well, there it is. Huh.
GG, man.
Linux Click and Run, 2002, Andy Warhol.
I counter myself.
I know I have no idea who Andy Warhol is,
It's
to be
just
honest.
handicap, guys.
Oh?
I'm too good, so I need this kind of handicap. What can they do otherwise?
Get better at Googling. Guides. Apple's M1 position mocks the entire x86. Okay, this one actually looks interesting. Alright, what do we got here? Okay, so Apple is updating iMacs with their new chips. All right, I mean that's kind of known. I'm not sure what we're supposed to get out of that. Sounds a little bit more revolutionary. 3 new iMacs, which are priced. Okay, sure. If you want to buy a Airbook, says you an M1 one. Okay. Alright, so then outside of that, selling a single CPU across a broader range of products. Then, okay, sure, why not? God, why are there so many fucking ads on this site? Jesus Christ. Speaks volumes to what Apple believes is a CPU fast enough at the quad core level because scaling wise M1's effectively a quad core chip. Okay. Or low power. Sure, why not? Then selling underpowered systems at certain price points. What? The old 21.5 max only with a dual core CPU? Wait, seriously? Holy shit. We've been running on dual core MacBooks for holy shit. Alright.
Bro.
What's LTT? I have no idea who LTT is.
If they go rush.
It's obvious. Oh, you mean Linus Tech Tips? Honestly, I don't really watch that much YouTube, to be honest. I remember he was just doing like a lot of like Linux builds or hardware builds, to be honest. I actually don't know if he does a lot of career CS career stuff. M1's the right chip for 699. All right, no.
Your bottom tower is under attack.
Okay. So custom performance now so high at such low power that the choice of chip inside the system has become irrelevant with a given product generation. It challenges OEM to consider how they might spec higher end systems if some of the higher price tag to the paper-fast CPU is rising. Yeah, but the thing is that it's not like Apple's chips are going to be used outside of the Apple ecosystem, so I don't feel like this is correct. It threatens both AMD and Intel with the idea that a CPU with just 4 high-performance cores is fast enough for the company to 1, call it an 8-core chip, and 2, position it against 6, 8, 10 Intel and AMD systems that sell for $1,500 in the desktop and laptop markets. So basically, they're saying that AMD and Intel have just been marketing dual-core chips as quad-core chips because they can get away with it at Apple.
I want to try and farm buyback.
Now, I feel like you could still do this with PCs because Apple's not gonna, create a chip that is going to be used in a PC. So AMD and Intel are just gonna like do whatever the fuck they've been doing for the entire time. Yeah, I know it's not CS news, but it's like stuff that I'm really interested in. How much system design do you actually learn on the job? It seems like a lot of the info tends to come from self-studying. Not necessarily. So let me give you an example. So whenever you come up with an idea for a product, a system, or whatever you want to do, you're going to always have like an ERD or a engineering review document, and it's going to encounter everything from end to end. It's going to talk about the considerations and questions that go into things. So for instance, let's say that you wanted to create you want to migrate your CI/CD system away from Jenkins and over to BuildKite. Well, the thing is that you're going to have to start looking up how BuildKite actually works. How does Kubernetes work? How does Docker work? Because that's actually underneath what is under BuildKite. And then also how you're going to shard your jobs, which is an equivalent to sharding on a database. So when you start dealing with a lot of the architecture of a system or a product or a service that runs end to end, you naturally run into a lot of these questions and considerations. So a lot of system design is basically just boils down to, can you think of what can go wrong at each one of these steps? That's it. And like I know a lot of people put an emphasis on like design Twitter, design Facebook, and I think in the recent years, last 1 or 2, I think companies have gotten a much better idea that essentially that engineering is broken up into 3 types. One is the product engineers, one is the platform engineers, and one is like the DevOps. And too many people have been asking these DevOps questions like design Facebook, design LinkedIn with a database and scaling issues. And that's essentially more for DevOps people. But for products, like how do you design something that goes from end to end for a system, like design design Battleship. That's going to be more or less interacting with services, and then you might also be able to interact with some databases and whatever. But for the most part, that part might mostly be focused on product or whatever area you are specifically geared towards. That being said, you should still kind of know what the tech is. You might not know them by name, like you might not know what a NoSQL database is, but you can at least identify the characteristics of them, because there's so much tech out there. Like no one can possibly know all the different all the different types of databases, all the clusters, all the different ways you can search on it, like Elasticsearch and shit. It's like there's just so much shit out there. No one can reasonably do that. So instead, I would recommend just trying to understand the characteristics of the system you need. And so this is where you get it on the job, really. So it's really hard to study, quote unquote, for a system design interview. It's 80% of it, 70% of it comes from your own experience.
Minion left. I'm chilling, guys. I'm chilling.
Do companies care about what major students graduated with for software jobs? Not really. As long as you can pass the interview and not piss off the interviewer, you're pretty much A-okay. I mean, they've been calling chips 4-core, 8-core literally over 10 years. I'm not really too familiar with like the hardware market, to be honest. I mean, I would not be surprised if that is the case, but alright. Looks like it's 8 p.m. Let me bring our guest on. I'll leave the game on while we're chatting in case you guys want something to look at. But I'll make the sound. Hey yo, hello. Hang on, I'm not hearing you. Yeah, that's right. Okay, I see your sound coming through, but I'm just not hearing you. I don't know why. What the? Hang on, let me try something. Let me try logging in with my client. Oh, okay, there we go. Hello?
Okay, now?
Yeah, I can hear you. What's up?
All right, cool. How's it going?
Hey, I'm doing good. Yeah, so thanks for agreeing to do this interview with me. I understand that you recently got a job offer at Microsoft.
Yeah, it's been it was good. Pretty happy. Did a lot of like prep work, but ultimately, yeah, it paid off at the end. So I'm pretty happy I did it. I basically kind of I kind of think of it in two ways. I did like sort of a low key, not as intense studying starting like almost a year ago, like, and then I kind of like did a more intense like lead coding. In the less intense part was just reading CTCI and EPI, the books. I kind of just did the problems in my head. I didn't really actually do them on paper or the computer. And then starting in September, so like almost 8 months now, I did like some pretty hard lead coding, like hardcore lead coding every day. And I think looking back, I probably would not have. I think the reading the books was pretty much a waste of time. It's all about like the active practicing.
Okay. Yeah. Let's actually start at the beginning. So, you said you were doing stuff for like a year. So just for people's clarification on stream, are you a student or have you been working in the industry? Tell us your story.
Yeah, I can introduce myself. I'm Jason. So, I guess my story's kind of unique. I graduated in 2013. So I started coding like 4 or 5 years ago. I did an online course. I was a liberal arts major, so I think someone asked like, does your major count? I was literally a art history major and government minor, and I went to a liberal arts school. So that's as far away from technical as I feel like you can possibly get. And I just kind of I did like some online courses, self-studied, and just did some tutorials and got into coding like around 2016. And then I just kind of parlayed that into like a really really crappy job at a no-name startup, and then just went up from there to a government contractor. Then I worked there for like about a year and a half, and then I'm at Capital One. Went to Capital One, worked here for almost 2 years now, and then I'm about to switch to probably Amazon. But I'm still interviewing at Facebook, so I may have it on site. I just did a phone screen yesterday.
Awesome.
So yeah, it's been quite a journey, but yeah, I feel like I've been learning so much these past 4 years. It's just like a matter of like devoting yourself to learning, like constantly learning, and frequently like you'll find yourself at a job where you're just like doing the same thing over and over again. You're not learning much, and then that's when, to me, that's when I tried to jump companies.
Yeah, I remember that
Um,
we had that conversation actually a little while back as well, and I think I mentioned that to you, right?
yeah, yeah. Yeah. At each job, like, because I was like looking at my resume, I noticed, okay, how many different times can I write like web dev? Like I wrote this feature in React and did this, and all of it was like really, like all of my bullet points on my resume was like pretty simple, like average web dev, maybe some back end hooking up, to an API to a front end. So then I started thinking, okay, what do I want my resume to look like? So I started thinking, okay, so the next level is, I should go for senior. Okay, so what does a senior engineer do? I was just like, okay, let me think of what a senior engineer does, and I'll just start doing those things. A, so I can put on my resume, and B, so I can actually learn, and have experience doing those things and learn from those experiences.
Mm-hmm.
Yeah, so I think that was a helpful when I realized that I could do that, and I just started doing stuff when no one asked me to do, and just kind of like became the de facto person in charge of this project, just because I just started owning a lot more.
Mm-hmm.
So yeah, I think that's a good thing for people to do if they're kind of looking at the resume and they're like, okay, how many times can I say, I built this feature in XYZ, and that's like pretty much all you have, right?
Mm-hmm. Yeah, so then I kind of like, I don't want to cut you off, but it's like I want to get to the part about you studying, deciding to make the jump, and how you found out about me.
Yeah, so I saw one of your videos. It was just recommended to me by the algorithm,
Mm-hmm.
by YouTube, I guess. And I kind of just dug deeper. I think there was a link to your document.
Mm-hmm.
And I read that, and that was a very impressive document. I felt like I learned a lot from that, so I just kind of was like, okay, this guy's legit. I'll keep watching his videos,
Mm-hmm.
and and I just went from there. And then I listened. I did what you said about grokking the coding interview,
Mm-hmm.
doing that course, and that was the one thing I felt like I was missing, because I was trying to leak code, and I was kind of like struggling, and I didn't really have a way of organizing all these problems in my head, and that's exactly what grokking gives you.
Mm-hmm.
Yeah, that was huge. That was way better use of time than reading those books, or even just trying leak code on my own and failing, early on.
Yeah, that makes sense. Yeah, so I remember, I think in our session we were talking a little bit more about I think being able to break down the problems, right?
Yeah.
Yeah. So before the coaching session, what would you think was your biggest weakness, and what were the things that you felt we talked about were the biggest impact on your performance?
Well, I think I still do this, but I think I'll rush into coding first, and then I won't. I'll try to rely on a pattern that I've recognized before. I guess this is a problem I still struggle with, to be honest. I'm not, a master of this by any means, but yeah, I think like I'll still do this where I like, well, oh, I recognize that, and I'll just start typing it up, because time is of the essence, and speed. If it's Facebook, you want to get 2 questions in, so yeah, you have this like feel that you have to rush through it.
Mm-hmm.
And also, like, I'll like book. So I got some interviews at like practice companies, and where my sole goal for those interviews was just to like hone in on that one thing. So like, okay, just do the clarifying questions, do the what else? Do the yeah, do the clarifying questions, do try to like break down the problem, run through some test cases,
Mm-hmm.
and yeah, and don't rush into the problem. And if you can just do that, hit those 2 goals, then you can count this interview as a success, even if you don't get the offer. So I did that with like Indeed and Zillow. I had insights for those, which I didn't get the offer, but those were essentially, I just kind of chalked it up as practice interviews, for the other companies. So yeah,
Yeah.
yeah. I just go ahead.
Sorry, I was gonna say, yeah. So, like, I think that's really important for someone to take away is that you're interviewing with these companies as much as they are interviewing you, and so it's like you might as well just take advantage of that and just use them as like practice.
Yeah, in Zillow, for anyone interested, Zillow gives out free lunch, so they'll give you like a Grubhub coupon, and you can get lunch. So if even if you don't want to work at Zillow, you can kind of just pass their online assessment, their phone screen. It's pretty easy. It's a carrot interview, and yeah, if you do carrot interviews, those are super easy because all their questions are on LeetCode, and there's only 6 of them, so there's not really that much to study for that. Yeah, and LeetCode Premium was completely worth it for me because I would just do the top 50 questions for the company before I, like starting a week or two before the onsite, and even if I didn't get the questions, it prepared me enough where like I was in, like I kind of knew what difficulty level. Like Amazon, they don't have like a set questions, but even if you do the most common Amazon questions, you'll be kind of in the right mindset as far as like difficulty for that company.
Okay. Someone in the chat asked, "What's a carrot interview?"
Okay, yeah, Carrot is like a third-party interviewing service or company that Zillow or any other like company will hire. So they'll hire Carrot and pay Carrot to interview you, and Carrot does the interview. So that way they kind of like offshore their to a third party they're interviewing. But that makes it easy for you because like all their interviews are very formulaic. And their questions are on LeetCode. They're not really that bad anyway. I got like, count the number of islands and like variations on that. But if you get text justification, that's kind of hard.
Gotcha.
So yeah, it's hard. That one's just hard to memorize.
Okay, for sure. So I want to dig a little bit deeper into like your issues before the coding interview and then how you just like at least before our coaching session and after them, because I feel like a lot of mistakes that people make are going to be the same. So like, just for the crowd, like other than the relying on a pattern and forcing the pattern, and I'm pretty sure I told you to really be able to dig down into the problem, be able to build it from the ground up and to test it, if I remember our coaching session correctly.
Yeah.
So what? I just wanted you to elaborate a little bit more on that. Like, what were the biggest takeaways from the coaching session? What do you remember vividly that stuck with you?
I think just in general, run through some test cases first, and try to like get the time complexity and space complexity first, because that will help organize. That's kind of like the outline to your code. If you know the time and space complexity, that's like half the battle's done. That kind of informs the rest of your code. Yeah, I don't remember much from the coaching session, to be honest. Sorry. I think it might have been a while ago.
That's fine. It was in January. But yeah, like if I can at least instill like 1 or 2 good habits from that 2-hour session, then I think I've pretty much done my job. Because it's not like something you're gonna go back to over and over and over again. It's like just getting those habits in you, and that's basically my job. At least that's the way I see it. So, okay, so after that, you decided to focus on testing, making sure that you actually understood what the heck you were writing before you actually did it. And so let's actually talk about going into these interviews. So before you were using them to just like practice, did you receive any offers or any on-sites before our coaching session?
No, I didn't.
All right, so then after that, sorry, go ahead.
No, I just said it was huge, the coaching session.
Right. So then after that, what were the interviews that you started doing, and how did you do on them? Describe your experience, especially with Microsoft.
Yeah, so I got phone screens at Rivian, Plaid, and Twilio, and then Amazon, Microsoft, Indeed, and Zillow. Out of those, I got on-sites to Zillow, Indeed, and Amazon and Microsoft. And out of those, I passed. I got offers from Amazon and Microsoft.
Nice.
So yeah, it was kind of it was kind of a funnel. It wasn't that many companies. I'm still actually applying to more, but to me, this is just sort of my my one bucket of companies I'm applying. I'm thinking of like, I kind of think of it as like buckets of medium to like most desirable to least desirable. This is like the median desirable companies. So yeah, anyways, Microsoft. Yeah, so Microsoft, they first give you an online assessment, and it's pretty easy. Not gonna lie, the first question is like, it's like fixing a bug in a very simple piece of code. So it's basically you make one line of change and then you're done. And then the second question was it was another question that was pretty easy. It was like objectively easy for like everyone can probably solve it. Yeah, it wasn't too bad. And then the third one was like a multiple choice question, basically a multiple choice quiz of like maybe 10 questions, some of which are hard. Yeah, some of which are kind of tricky, but it's like, here's a bunch of functions. What's the time complexity? And you have like nested functions in functions. And what's like another example, what's the faster than if it's sorted, if a list is sorted, what's the fastest, way you can find a element in a list, you use binary search or what's the time complexity of it, log. And then the fourth one is kind of hard. I remember I actually failed it because I'd spent too long on the first couple questions the first time when I did it. And then I didn't have time and I couldn't figure out basically the fourth one. So I actually failed the online assessment. And then I talked to my recruiter and he's like, yeah, you can just do it again. So definitely ask your recruiter if you can do it again. Because it's in their interest to actually make you pass. So they'll give you another shot at it. If you say, oh, I was close, and you kind of say, oh, I ran out of time. This direction was unclear to me. So that's why if you have like a good reason, they'll probably give you another shot. And I don't know if this will always happen, but he gave me the exact same online assessment. So yeah, I guess I lucked out, or I don't know if that was by design, but it was the exact same thing. So I knew what the answer was because every time you fail a question, you go back and kind of do it on your own. And that's huge too. Yeah, there's definitely questions I failed on Rivian and like in other questions in other companies, I forget which, but I went over them at the end, and some of them you see multiple times. So that's yeah.
So going on
Yes,
to on-site, did they ask you any system design?
Yeah, Microsoft. So I have a friend that works there, and he's worked there for like a year, and he's sort of like a level 61. So he's sort of like entry level-ish level, and he said that basically Microsoft as a company, they're trying to move away from leak code and do more focus more on system design, because that tells you more about a candidate's actual skill or knowledge than leak code, which so they were basically anti-leak code, pro system design. And if you're good at that, and I think it's easier to get good at system design than leak code, then you could get in pretty easily, although it is very team based. So so I did a hiring event, and in a hiring event, you have two teams that interview you. And either you basically need to score well in all of them or well enough. So I remember I had one team that gave me really hard questions. Another team gave me really easy questions. Was like a lot easier. So you can kind of see like it is very team based. You might get two really hard teams or two really easy teams. And the hard team was the identity team. And I don't know if I should say this.
Probably
but
don't. I mean, probably don't.
Yeah.
I don't want you to incriminate yourself. All right.
Yeah,
So
okay.
I know you've talked a lot, but let's quickly summarize.
Yeah.
Before the coaching session, you didn't really have that. You didn't have any offers, and then now you just bust through the door with like 4 fucking offers. two, like with Microsoft and Amazon being two of them. And you mentioned they are focusing a lot more on system design. And I don't think we did any coaching on system design. So this was more of something that you, I guess, taught yourself or you already knew how to do.
Yeah, I kind of just taught myself that. And I think for system design, the key is like, think of it as a performance. So basically you have a whiteboard or like an online whiteboard, and my goal at the end of the system design was to fill that whiteboard full of like, not just like designs, but words and like proof that I was thinking of my thinking. So if you're like thinking, okay, should I use SQL versus NoSQL? Just write, SQL versus NoSQL, and then just start writing the pros and cons, like very like short, like, scalable multi-master versus, especially if you have like, if you're doing like, comparing between two like caches, like Redis versus Memcache, just write out like you want to like, you want to think like you're performing and you're like writing all your ideas down, and then at the end, if like, so because if you just say it, they might forget that what you said, or might not understand when you're speaking. So if you just write it down at the end, you basically have a huge board of proof, and then that's going to look very impressive to your interviewer, because he'll just see like all this thinking, all this work that you've done, and it's going to be in his face. So he can't like forget what you said in the first 5 minutes.
Mm-hmm.
Yeah. I mean, DDIA is pretty intense. It's pretty deep. So and a lot of it is like it goes deep into like things that you probably don't need to know. But the very end of it, with event-driven architecture is, it's pretty useful, because like a lot of things require event-driven architecture. Like if you want to design like payments, to like, you need event-driven architecture for like discrete. Sorry, I forgot everything now. Just like discrete, like buying, selling, and transactions.
Mm-hmm.
Like even like an Amazon store, there's just so many like purchases or buys and so much volume that you can't handle it by a normal like REST call, for example. So yeah, let's see. Basically, like, I think someone said this, but if you're like going for a regular like entry level L4, you probably don't need to do the like comparing alternatives. You don't have to go deep into each service or database that you're talking about. That's probably more for a senior role. But if you do that, and it's not hard to do that, they'll see you much more positively. So even though I wasn't going for senior roles, I did that anyways, knowing that, okay, at least I have that if I screw up other things in my system design, or if I don't complete it or whatever. And just have like a kind of a list of things that, okay, if I go with event-driven architecture, then I'm going to talk about Kafka. I'm going to talk about handling the streams and doing joins on the streams to get certain data relationships, and other things like that. Just have like if I go this way, I have this set of points to talk about and write down on the whiteboard. That way you can kind of group your ideas together, and that's going to help you memorize it, just by grouping your ideas together. And and then you'll have that basically in your back pocket.
So the best way to really think of, to summarize what you just said, is that every single like design choice that you make kind of forces you or naturally lends you to another design choice that's pretty easy to predict and follow and memorize in a way.
Yeah, exactly. And like the thing about system design is there's like unlimited ways to design Twitter or design anything. So even if you're not right, you could theoretically be right, and that's what, as long as you can like prove it and handle the parts where your design might be weak for this specific problem, then it's still legit.
Yeah, that makes a lot of sense. Yeah, so you definitely talked a lot about the system design. I would say that I think the big takeaway for everyone is like, well, actually, why don't you do it? What do you think the biggest takeaway from all this is? Because you touched on a lot of points, and it's very useful for a lot of people. But if there's one thing you could tell someone who had an interview in 10 minutes, you know, like they have they have an interview in 10 minutes. What's one thing you tell them?
Ooh, I mean, I would say I hope you did the preparation because I think it's important. The main important thing for me is like see all this prep work and studying as investment because theoretically you'll probably jump companies multiple times in your career. So just think of all this work you're doing now as an investment, not just for this round of interviews, but for your future, interviews when you're, a senior and your staff.
Mm-hmm.
Like all of this is just your foundation work. And every time you restudy again, you're going to get better. Right. So, build the foundation now. Just put all of the work up front. Like I said, I studied pretty much a year passively and like 8 months very actively.
Mm-hmm.
I did I'm almost at 400 lead code problems now, just because I know. Yeah, yeah, just because I know that this is there's a lot of money riding on it, to be honest, and and it's kind of worth the investment up front, and later on it's going to be that much easier. So if you're 10 minutes in, you have the interview in 10 minutes. I hope you did the work.
Yeah. Okay, so I actually wanted to touch a little bit on like the text stuff, and to get a little bit into nitty-gritty details of the system design, because there's a lot of tech out there like architecture, Kubernetes, Docker, all the SQL databases, all that jazz. How do I describe this? How did you find, or what was your way of remembering all these different techs? Was it just like pre-planned? You knew you were going to either use Redis or Memcache, or what was it?
Yeah, I guess I kind of learned. So there's really a defined amount of information you didn't learn. So I just learned it, and I use spaced repetition to learn it. So if you read DDIA, if you do the system design primer on GitHub, if you even read like one other thing, probably Grokking, or even the Alex Zhu book, you're going to see the same thing everywhere in all three places. So if you just see it everywhere, you probably won't forget it. So yeah, all that stuff. I don't think it was like too hard to memorize just because you see it in every resource you go to. Yeah, and those are just I guess those are more of the basics that. That's like if you any system design resource, that's like the first thing you're going to learn is what is a database, what is data, things like that.
Mm-hmm. Yeah, I think my take on it is that it's not important that you memorize this is like Redis, Memcache. You just identify the characteristics of the database or the component that you need. Yeah,
you'll see patterns like, okay, do I need something with like very good atomic transactions that can be slow, like things like metadata. You put that in relational. If you need very scalable and you don't need like joins or any relationships between the tables, then you can do NoSQL. Those are just like you'll definitely, like you said, notice common patterns for each technology that that you could probably use, and I think it should be relatively obvious which one to use.
Mm-hmm. Yeah, that makes sense. You do enough of them, then you just start recognizing the familiar technologies, and then you start mapping them to their characteristics, and so on and so forth. And as you said, you just make the argument for it. So, that's kind of all the ground I want to cover for this as far as the system design interview goes. Any final thoughts that you want to share with the interview before we go to like your offers and stuff?
No, I think that's good.
Okay. Yeah, so let me see. There's someone in the chat who asked how many leak code questions. You've already answered that. Chris asks, Did you ever get stuck in an interview? What did you do, and did you ask the interviewer for tips?
Yeah, definitely. When I got stuck in an interview, let's see what I do. I just try to run through some examples. I think that was a tip, Edbert. I think you mentioned that.
Mm-hmm.
Yeah, that was really helpful. And then you'll see patterns if you do just in yeah you'll see like patterns sometimes. Like if you get stuck, okay, this you kind of dive deep a little bit into why you're stuck. And just kind of go through your memory bank of okay, what patterns do I remember that is sort of similar to what I'm seeing now, and then you can kind of that's sort of how I do it. I know you're not supposed to use patterns, but that's sort of like what I do a lot. So
No, I mean patterns are an optimization on top of your ability to really break down the problem. So
yeah, you can just like flip through the patterns in your brain, and because you've done so much prep work, you'll definitely see, you'll definitely see the patterns.
All right, for sure. So let's move on ahead to like the day you got that call saying, "Hey, you passed." How'd you feel?
Oh man, if I I felt pretty good. So yeah, Microsoft was the first offer that came in, and that was surprising because like I remember after the the onsite, I literally got the automated reject email. I was like, okay, fuck it, that was the end of that. And then apparently, then like basically 3 weeks later, right after like the day before I got the Amazon offer, I got an email from my Microsoft recruiter, and he's like, hey, I'm guessing you probably thought I forgot about you, but I've actually been working on getting you an offer this whole time, working with the team and an offer. So like he's like, are you still interested in joining? And I was like, yeah. And then he's like, okay, great. I'll a recruiter on their side will reach out to you and and set things up. Basically.
Wait, hold up. You said you got an immediate rejection email, and then you got an acceptance. What?
Yeah, that you know what? That was the case for Amazon too. I logged into their like job portal, and they're like no longer under consideration. I was like, okay, fuck.
What the fuck?
I think you don't listen to that because I think that just means you're done interviewing. It doesn't mean that you're actually rejected. So if you get that, and I looked that up in blind too. Your only source of truth is the actual recruiter. So I always ask him or her if you're unclear.
Oh my fucking okay, gotcha. Yeah. That's a new one. I did not ever think that was actually the case. Like you received the rejection email, you're just like, I'm done, right? I'm done. There's nothing I can do.
Yeah. I mean, I don't know what happened. It could have been possible that like they offered someone else the offer, and then that person rejected it after 3 weeks, and then I was next in line, and so or they're just like that slow. And Microsoft is known to be like really really slow.
I mean, I have heard that happening actually, but usually, at least back at Apple, what we did was we would set out the offer, feel it, and if they came out with a no, then we move on to the next person on the list. That's why we were slow. Yeah, so it's kind of weird that they would even full on reject you before accept you. But you probably felt really good about that interview too, right? Or
yeah, I felt so. Yeah, I kind of. So what happened with the Microsoft interview? I think they said right after the onsite, I did well enough where they're like, where the recruiter said they wanted additional interviews, like one additional interview to kind of confirm things. I guess I didn't do well enough to get an outright pass, but I didn't fail it completely. So they asked for one additional interview from both of the two teams that you interview with. I remember the first one, the guy was kind of a jerk, and I didn't vibe with him at all. So that one was a pretty clear no. And the second one, I remember I did pretty well. So I was honestly surprised I got a reject after the second one. And then I guess it just took a long time on their end.
Yeah. Do you know if you were applying specifically for a senior level position or L4?
I was so the recruiter gives you an application and you fill that out, and my application was level 60/61. So I think that's I don't know what that is. I think that's probably entry level, or just under mid level. I'm not sure.
I'm bringing it up on screen right now. Level 60/61 is L3 L4.
Okay. Yeah.
Oh. Okay, I mean that's still really good. Like I think the 50-50 was whether or not you were 60 or 61 actually.
Yeah. Yeah. Probably. I don't know.
No, that's still
But
really dude, regardless, that's still pretty good. I'm not it's like I'm not gonna knock on that. You obviously know what you're talking about enough to get like a shit ton of offers, you know. So you're honestly whatever you say right now is kind of gold, you know, to the audience right now.
yeah, I mean, my goal was just to get an offer. Period. I wasn't like from Fang and Fang Mula, I guess.
Hmm.
So yeah, I'm happy I was able to do that. I wasn't. I guess I didn't care too much about. I was hoping for mid level just based on years of experience, but
Hmm.
I actually looked that up on levels, and apparently, like a lot of people with like four, I've seen 4 to like 6 years, even like they got L4 at Amazon. They in so that was kind of, I guess, reassuring to know that I'm not the only one with like, almost 4 years experience being like at L4.
Dude, let me tell you, like
Yeah.
people have this misconception you get promoted every 2 years. No, no, that's not how it works. Basically, you're looking at 0 to 2 years is your L3, 2 to 5 minimum. Remember, 5 is the minimum for L4, and then beyond 5 is you can start looking into senior. So my situation of like being L4, like sorry, senior level, like 4 years out of school is completely abnormal. I think too many people really get this misconception of like, oh, if the minimum is 5 years, then I need to be promoted in 5 years.
Yeah, yeah, yeah. That's a good point. Like what we've seen is just like probably a small subset of what the majority of people go through. Like we just see the great, great stories on Blind. I have 3 years and I'm a senior or like things like that. But yeah, I'm sure like in the vast majority in real life, people at very high experiences are getting mid-level. There might have been even a 13 years experience on levels where he got L4.
Mm-hmm. No, that's completely reasonable, especially if your background isn't just charting out product and moving on.
Yeah, yeah, exactly.
Heck, even at Apple, like there was like some basically ICT3. No, ICT3 engineers who had like 12 years of experience. This dude was like grad school, 33 years old. He was the same level as me.
Yeah.
So, like he was like 33, 34. He's still ICT3. Like, there's no shame in that. The leveling system doesn't really like. You're not. It's not. It doesn't determine your self worth, or it doesn't determine necessarily your skill.
Yeah.
It's just like the level is just what it is, And if you perform well enough, people will recognize it. That's all it is.
Yeah, I kind of see it as like, okay, I didn't even have like a technical major.
Mm-hmm.
I'm literally a liberal arts major. This is probably my 4 years of CS,
Mm-hmm.
this of job experience right now,
Mm-hmm.
and everything on top of that is gravy.
Right.
So, yeah.
Really quickly, what was your impression of the Amazon interview? I usually hear a lot of really good feedback and a lot of really bad ones. Which one was yours?
Yeah, it was. I think it was good. I would say it's good. So the first 3 were pretty pretty standard. So I got like let's see what problem. It was like sort of a heap problem, like a array and heap problem for the first one. That was pretty easy. I had to sort the array first, and then I came up with the heap solution that was optimal later, and then I had like the word search problem in LeetCode, if you guys know that. And then for system design, the guy, like the interviewer, was a manager for Alexa, and he kind of switched the question up because basically because he said like, oh yeah, you it looks like you've studied this before. So which is like, yeah, of
Too
course I
easy for
study.
you.
Of course I study system design, like I'm interviewing. And then so then he switched up the question, and then I just did that one too. And the fourth one was interesting. That one I think was the bar raiser because the guy it was basically an OO design problem, which I wasn't expecting at all because I thought I was interviewing for L5 at Amazon.
Mm-hmm.
And I heard that's only for new grads. Mm-hmm. So he gave me that. I was kind of confused, and I wasn't ready for it because I never prepped it OOD at all. Mm-hmm. And then not only that, he would like basically interrupt you and kind of like put pressure on you and like basically try to mess with your mind. Like he'll say, oh, you should have done it this way, and the way he was saying was like basically what I said, what I just said.
Mhm.
So I think the test is to really like stand your ground and stand up for your ideas and say, oh yes, stick up for yourself essentially.
Yeah, if you believe in your ideas and reasoning, then you stand up for yourself. I mean, I'm that kind of interviewer, not gonna lie, to a little extent, but I'm not gonna flat out like lie to you, you know?
Yeah, he did some like crazy mind tricks, Jedi mind tricks on you, but I think that's probably where I got down leveled. I remember I kind of caved a little under that pressure, but yeah, got the offer again. So
Yeah, it was an L4 equivalent, right?
yeah, exactly.
Nice, mid-level, super solid. All right. Yeah. So to wrap things up, you got your 2 offers. Were you able to play both the offers against each other to negotiate?
Oh, that's still happening right now. So I was just told I passed and I'm getting an offer, but we're still like setting up the numbers, and I'm still interviewing with Facebook and I have Google on Monday. So I'm still interviewing, and I'll just like leave Amazon if I get Facebook, either one. But yeah, I mean, I'll just see what happens and sort of feel it out. But
you think you're gonna get it?
I don't know. We'll see. I don't think I'll get Google. I think I'll get crushed pretty hard by Google, but I think I have a shot at Facebook. I've been studying the Facebook questions pretty intensely.
Dude, you should do Fang Bingo with me.
Yeah, that's the hope.
Gotta catch them all, but you know what? It seems like you're on an upward trajectory. The results speak for themselves. You've knocked out interview after interview. You've gotten the results. You've gotten the offers. You know, I'm really hoping that you get these 2, man. And if you do, let me know.
Yeah, thank you. Appreciate it.
Yeah.
Thanks for all your help.
Sorry, go ahead.
Yeah, I said I appreciate it and thanks for all your help.
Yeah, for sure. If there's any final thoughts you want to share with the audience, if you can also see the live stream, there's also some questions that people have been fielding. It's your choice if you want to answer them.
Yeah, let me go into. I think that was messing up the audio, so I closed out of YouTube. But
Okay.
I can.
Yeah, you can mute the stream. But yeah, no. I'll talk while you're pulling it up.
I think that. Okay, wait.
Yeah, I can kind of hear myself.
Okay, let's see. Yeah, I did a online boot camp for Flatiron, which was okay. I think it got me off the ground, but I think the vast majority of what I do at work was self-study. So I self-studied JavaScript in the boot camp, taught you mostly Ruby on Rails and a little bit of JavaScript at the time. I think it does more JavaScript now. I'm about to. I'll probably accept Amazon. I haven't accepted it for sure, officially yet. Let's see. I work at Capital One right now. Oh, Rivian. Yeah, Rivian was a good interview. That was literally my first phone screen, so I was like literally caving under pressure. I was just so nervous, and I think that's a huge thing. Like set up a lot of interviews just so like you know what the pressure feels like when you're on the spot, and you can like kind of get used to it, because that will like I feel like sometimes that pressure just turned off my ideas. Like my brain just stopped working. I couldn't think. So it's super important that you guys schedule some like practice companies to feel that pressure in real time, without like without it being your most desired company, without that you really want to get. Okay. Systems design. How much? I don't know. Well, I guess there's still. I guess technically they said I'm getting an offer, and I met with the hiring manager. So basically, the hiring manager is just the last step. What happened was the hiring manager told his recruiters to basically he connected me with his recruiters. So I'm supposed to get an offer soon. So I technically don't have the numbers yet, but I know they told me I'm getting offers. And thus I can't tell you how much time they're going to give me.
Right. Yeah. I think that's all the questions. I think let's cut it off there. Yeah. Any final thoughts you want to share with the crowd?
Just like I said before, just think of it as take the long game approach, long term approach with this. It's it's really important, obviously for your career to move up. I mean, Capital One, I can answer those questions if you want.
I got one more guy. I'm gonna bring on for coaching. So yeah, make it really quick.
Yeah, I just do like mostly front end and full stack work. At Capital One, you end up doing a lot of DevOps too. So just mostly full stack work. You do learn a lot on the job, and then you stop learning anything. So that's when you leave. And you kind of get used to it. Like every job, you'll get used to it, and then you won't learn anything, and then that's when you have to switch.
All right, man. Thank you so much for sharing all your tips. I think I learned a lot myself. And I'm really hoping that you get these last two offers, man. Let us know how you do in the Discord.
Okay, cool. Thanks, Edward.
All right, for sure. Take care, man. Right. So let's bring on our next guest. That was actually really nice. Hope you guys learned something about that. So right now we're going to switch over to the technical interview. And so we're going to bring on the same guy, Devin, from last week. And he is going to report in on his progress, hopefully. Can you talk to this guy on Discord? Yeah, just ping him. He's just joined the Discord. Ping him. He should be Jason, 111 or whatever, and you can definitely have a chat. So Devin's gonna be joining us right now. He is going to he's gonna hopefully show us his progress, and with any luck, he just recap last week. He didn't really draw out the examples or run through things step by step. So let's see if he fixes that. So with that, Devin, welcome to the show.
That's the hope, man. Dude, listen to that last guy. I feel like I have no hope for Google after listening to that guy.
I mean, keep in mind that he has like 4 years of experience, and look. If you should also see it in a positive light as well, because if he can do it, then honestly anyone can, as long as they put in the right effort.
That's the thing, though. I'm putting in 4 weeks. He put in 4 years. Damn.
Well, 1 year of studying, 4 years of career. So yeah, catch us up on how things have been changing. What you've been practicing, what you've been focusing on. Give people a little bit of a recap who weren't here last week.
Yeah, so I've been really just doing grokking the coding interview, trying to learn all the different patterns. So I've gone through pretty much all of that except for dynamic programming, which is what I'm going to do this weekend and probably most of next week as well.
Mm-hmm.
And during that time, I'm also going to try to run through like more random questions, like more interview type questions rather than just like the pattern practice questions, to try to get like more pattern recognition down and whatnot.
Mm-hmm.
So yeah, that's kind of what I'm doing right now. And then like to kind of build on what we talked about last week, I've definitely I've gotten a little bit better. I've been practicing like building out the examples and the laying out the problem a little bit more. I'm not doing it perfectly yet, of course. It's only been a week, but I'd say I'm at least better than last week. Hopefully, we'll see. I guess.
Okay. Yeah. So recap: just building out shit, and making sure that you can break a problem down step by step. So yeah, let's start with a warm up problem, get you ready, and then we'll dive into whatever the heck that you might have. What other problems that you're gonna have?
Yeah. Are we using the same doc as last week, or you have
send it to me, and I'll open it up again. I just need to pull up I need to pull up another problem for you. This is gonna be like a warm-up problem. Again, just treat it like as if you're doing it competitively and taking it seriously, or as if it's a actual coding interview. So let me pull up a problem. And yeah, you have a lot. I remember you said that you did quite a few leak code problems, so I need to find something that works.
I've not done like any leak code problems.
Seriously? Okay, this will be a little bit easier for me to come up with then. I wonder if I should do one that I haven't given. I mean, that could be a little bit hard too. Because
I think my leak code. Sorry.
I was gonna say, it's like if I give you one that's a little bit harder, then I'm not gonna get the right read on you. So. Let's see.
Yeah, I was just gonna say I think my leak code pie graph is like 10 to 15 problems, and like only 2 of them might be mediums, if that.
Gotcha.
Really haven't focused on it.
Okay, let's open up Microsoft Explorer for me. All right. Yeah. So the pointer one, yep. Got range, graph, yep. Leave some. All right. So let's try to give you something along the same level. Okay, I'm going to go ahead and switch over. Give me a second. And then I have the timer up, so let's get ready to go. So, build a minimum height tree from a sorted array. So what do I mean by this? Which means, I suppose I gave you an array 1, 2, 3, 4, 5. You know, here, let me zoom in at 150 just so people can see this. Suppose I gave you this 1, 2, 3, 4, 5, right? The tree that you would spit back to me would be something along the lines of 1 with 2 and 5 as the children. So just to make this clear, 2 and 5 as the children, and then 1 as the left child and 4 as the left child here. Why is that? It's because this is the tree that, if we were to assemble it, would give us the minimum height. I mean, you could, in theory, what you could have also done is done this 4 and then switch it with 3 and make it the right child of 2. But overall, this is just one of many answers. So I want you to be able to build that tree.
Okay. Let's see. Okay, so it seems like then, if I can write out my own example then, if we just do something like, is the input always going to be sorted like that, or is it random?
So it's always going to be, the array is always going to be sorted.
Oh, sorted array, got it. Okay, cool. So then if we just write out another example here, like 2, 4, 6, 8, 10. And let's do a few more numbers on this one actually. 12, 14, 16. So what I'm thinking is, if we want to do the minimum height, we'll probably want to start from the middle, so that way we get an even split on both sides. So what I'm thinking is, if we take like 10 here. So I'm just going to build out a tree from the middle and see what happens, and that'll kind of give me an answer as to if my thinking on this is correct, that starting from the middle is the right idea. So 10 will go left, right. And then, so I guess the question from there is, do I want to start from the middle and work out, or just set the middle and then work from the outside in? Because that will determine the size of the tree. Because if I start from, because if I start from there, okay, I think I see this then. I'm going to want to keep starting from the middle on both sides, because I want things to evenly split left and right. Because if I start like directly to the left or right of the middle, it's just going to keep falling down one side, because it's either going to be greater or less than, depending on if I'm left or right of the middle. So here we're going to say, so we started with 10, and then we're going to go to the middle here, which we're just going to take the upper of the even numbers, so we'll start with a 6. And then on this side, we'll get the 14. And then on the follow-up, let's see, how would we get to there? So now we have 2, 4, and 8 left here. Let me see if I can strike through on this or something. What is it? Format. Alt-Shift-5. Okay. There we go. So we have those numbers used. Okay. So from here, we can say we need to basically split the difference between the left side middle. So let's just focus on the left side of the tree now for right now. And then ideally, this would be happening at the same time, but just for like simplicity and trying to figure out the thinking, I'm going to start on the left side only. So we set the middle, and then we set the middle of the left side. So now we need to split the difference between those two again. So now we need to take the middle between 6 and 10. So here, let me write this out. Start at the middle of the array. Put the middle of the left side into the left side of the root 10. Now we basically have to go. It's basically like starting at the middle all over again. We have to do left and right and go to the middle of each. So our upper bound on this case will be 10, and our lower bound will be 6, and the middle of that is 8. So the 8 will go to the right.
Okay.
Actually, technically, I should do this in order. So what we should actually say is like, we'll do 4 first because we did left once, and then we want to keep doing left. So basically, it's kind of like a reverse DFS, basically, in a way. If we want to stay consistent with that. So 4 gets placed into the left. Then we come back up, and we want to go right, and we want to look at the middle between the root and the previous node above that, which is going to be 8. Oh, sorry, actually, before 8 happens.
I would say you're getting a little bit. The array is getting a little bit messy. Just as a quick pointer, I would recommend you split the array just for the sake of cleanliness of your own work. Not necessarily as a representation of the operation you're doing, but just a small thing. That's it.
Okay, yeah, I'll write out 2 arrays here.
Yeah, might make it easier for you. That's it.
I'm gonna just duplicate 10 in both of them.
Okay, sure. So
we
let's
can keep track.
let's say you got through 10, right? And so you're gonna have left side. You're gonna have 2, 4, 6, if I understand what you're saying, and then on the right side you're gonna have 12, 14, 16.
Yes.
Okay, cool. Yeah. So go ahead. And yeah, go ahead.
Yeah. So we placed 4 and 6 already. So I'm gonna cross those out. Yeah. So we want to basically, like I said, it's kind of like DFS. So we want to keep going down the left side. So right below 4, we're gonna place our 2 going down to the left of that, because it's gonna be like half of what's left, which is just gonna be 0. So we can cross that out, and then we come back up to 4. Basically, you just want to keep looking to the left of the number.
I recommend splitting your array again just so you keep your work clean. Because you already did on the first step. Why not just do it again? It might make it easier for you.
Yeah. So, okay, we said 6 is the middle, and then so we have 2, 4, 8. And then we put 2 and 4 down the left, and now we have 8 left over. Lost my train of thought. Let's see. Let me start back up here at the top so I can follow what I was thinking. All right. So we placed 10. We have this array left. Now we want to split this array in half again. So that's going to give us 2 and 4, 6 and 8. Well, that's not quite right, because we want to place 6. Okay, now I see it. We place 10. We take this side of the array. Uncross that out.
Okay.
Or I can't, whatever. Okay, so now we take the half between the half mark of this new array, which is going to be 6, and we place that.
Okay.
So now we have 2, 4, 8.
Okay.
Get rid of these. So now we take the half of that again.
Okay.
And we place it.
Hold up.
Wait.
What did you do before that?
Sorry. So we place 10.
Okay.
And we took the halfway mark of what was left of 10, which is
Okay.
6. And then we place 6 on the left of 10
Okay.
because we're looking at the left side right now.
Okay.
So now we have 2, 4, 8.
Mhm.
So basically, we want to say when we placed 6, sorry, that should be, we got left with 2 more arrays, which was 2, 4 for the left and 8 for the right.
Okay.
So we're going to ignore 8 for now because we're not looking at the right yet.
Okay.
So now we say, all right, what's half of 2 and 4? We're always going to take the upper here, so it's going to be 4.
Okay.
So we place 4 to the left of 6.
Okay.
And now that leaves us with an array of 2. And we're still looking at the left side. So 2 gets placed on the left because that's the only element left.
Okay.
So now we come back up. Sorry, so just to clarify, when we get to 2, 4, there's nothing to the right of the element we're placing, so that's why we don't need to worry about the right side here.
Sure.
Yep, so then we come back up to this node 6,
Mhm.
and that's when we have 8 on the right side.
Mhm.
So we'll place technically the halfway point, which is just 8 because it's the only element.
Mhm.
So that gets placed there.
Okay.
And now we can look at 12, 14, 16 on the other side because that is everything for the left side done.
Okay. I mean, it seems like you know what you're doing, so you don't need to do the rest for me.
Okay. I would like to finish it because
Sure.
I don't quite have the pattern in my head yet.
That's fine. Go ahead.
Yeah, so we have the right side array, which is 12, 14, 16, and we'll place the middle of that into that side. So now we have 2 more arrays of 12 and 16. So the left side gets placed as a 12. And then there are no more elements left on that side, so we place the right side, which is 16. Okay, so that will be what the answer looks like for this given set.
Okay. I think that's perfectly reasonable. What do you think?
Yeah, I think that is a good approach. Starting at the middle and then basically splitting at the halfway point continually, left and right, until you get down to no elements remaining. I think that's the best way to make a minimum height tree.
Mm-hmm. Okay.
Yeah. So from here, let's see if we can write out kind of like some pseudo code to kind of give a general outline to how this is going to happen.
Mm-hmm.
So let's say so off the top of my head, I'm thinking this is probably going to be recursive. So that's where I'm thinking right now. So I'm thinking my recursive function will probably have a few inputs. So let's see, we'll have like a function recurse create, we'll just call it recurse create, like we're recursively creating the tree. And then we'll have like an input of a input numbers, and that's going to be an array.
Mm-hmm.
And then so that's going to be like, it's good for the first step, it'll be the entire array, and then when we recurse down, we'll be giving it the left or right half. And then we'll see what other elements we might need there. I'm not 100% sure yet. Yeah, so I'm thinking for the base case, it's going to be if the number of, basically if this length is 0, then we're out of numbers to place, so there's no need to continue. So then we'll just, we'll return from that. And then let's see. So now we need to figure out what our middle element is.
Mm-hmm.
So we're going to say start is going to be equal to 0, start of the array, and then the end is going to be equal to the length of the array minus 1. So that'll be our lower and upper bounds. And then we need to get the middle as well. And so middle element is going to be, what is it, start plus end minus start divided by 2. That's the middle element. the index of the middle element. And then from there, we need to actually place it. So I need to start thinking of the actual data structure. So we'll have like a node that we need to pass in as well for where we're actually at. And then node's going to be simple. Node's just going to be like a class node. And that's just going to have like left, right, value. Something like that. So, and this is actually going to be like a helper function. Probably we'll just make like a top level function that calls it just for ease of use. And then, so from here, we get our middle element, and then we say we got to set the root dot left equal to, hold on. No. We set the root equal to the middle of the current, sorry. Root dot value is equal to the input numbers and then the middle element. Yeah. Yeah, so that sets the current root or the current node. And then this is where we'll start recursing, which is we'll do root dot left is equal to, and this is where we recurse into, and we'll root dot left is equal to, hold on, why did I need root dot left is equal to?
Why do you need to pass in root node?
Yeah, I was just actually looking at that, thinking now I don't need to do that. I can just return the root in here if I hit the base case. So I don't think I actually need that.
Okay. Well, again, root is, what do you mean return root? There's nothing, so.
Oh.
What do you think would be the right answer if I gave you a empty array?
If you gave me an empty array, so here, actually, let me write out like the top level function. I think that'll help us visualize a little bit more.
Okay.
So we'll just have like function create tree, and then that's just going to take an input of numbers. So in here, this is where we're going to say node root equals new node. Actually, do we want to set the middle element here and pass it in? No.
So what do you want your recursive function to do very specifically? What is it? What is the input? What is the input and what is the output?
Yeah, let me define that. I want recursive function to do, I want it to set the current node's value and then output, sorry, set the current node's value and its left/right children. And then if the output is, I want it to output the current node with the children attached. Does that make sense?
Yeah, that's fine.
Okay, so then what I need to do is I need to, basically it's going to have to take the root in because it's going to just return basically every time we call it, we have to give it the left or right that we're going with, right? So here, for example, we need to pass in the input numbers and the root dot left. And actually we need to split this. We'll figure out what we're splitting that with later as soon as we kind of figure this out. Yeah, so we need to do that twice, once for left, once for right. And actually, I'm gonna pull this out, and we'll call this left numbers, and then we'll actually copy that and do left, right. Yep, so we need to split the array. So we need to, or not split, it's slice. Slice. So for left, we're going to slice from 0 to middle elements. Slice is, I can't remember if slice is inclusive or not. This is where my JavaScript knowledge fails me.
I think we talked about this last week, but you know what? Just pretend that it is. Let's consider it inclusive for now.
Okay. I think it's not, but I can't remember for sure. Certain. And then this one's going to be middle elements +1 to the end of the array -1.
Okay.
Left array, right array.
Sure, I get the idea. Now, do you think your answer is complete?
Let's see. So we haven't finished up here, but
Okay.
that's not the important part right now. Let me see, or let me analyze the recurse function, see if we're good here. So let me just run through this with like a really simple number set, just to like 1, 2, 3, 4, 5, like we did earlier.
Sure.
So when we come in, we're going to pass it the and then return root at the end. So when we come in, we're going to pass the input numbers and the created root. Oh wait, we don't have to return root because it's passed by value. Yeah, or sorry, by reference. Okay, so we come in, we have our array, we have our root. There are numbers in the array. Okay, this is where I'm going to be focusing on when we get down to the last few numbers, because I need to make sure that when we slice, we're slicing into a 0 number, like an array with 0 numbers. So that's where I'm going to be focusing when we get down to that point. So we start at 0, end at input length -1, so it's 1 to 5. Our middle element is 3, so we set this element to 3. So we have 3 on the first element, and that's left and right children. We come back, left array is going to be a slice from 0 to -1, so now we get our left array, which is 1, 2. And we get our right array, which is 4, 5. Then we recurse and we point.
Hold on. Hold on. What is this root.val? You said you got 3, right? That's fine.
Yep.
Okay, just keep going. You're fine. Keep going.
Okay. Yeah, so what I'm looking at right now is that what I'm going to have to do actually before I pass these in is... Yeah. Okay, so what I'm looking at right now is when I pass in like root.left, that's just going to be null. And it's not going to work here. So I'm trying to actually figure out where I should place the initialization of that new node. So if I place the new node initialization out here, that's not going to work. And then we bring in root. So we pass in a null root in the beginning. We can set it here. So right here, we can just say root equals new node. And then we get rid of this definition here, and we just pass it a blank object. Okay. So I think that'll do.
Does that work?
So that's what I'm looking at right now. pass in that, makes new node, and then come down here, pass in, that's basically null, and then that's going to get set by that. Same thing happens there. Yes, I think that works.
No, it doesn't.
Oh.
Do you know why?
Probably, but I'm not seeing it right now.
Root.left passes in a null, right?
Yep.
So that's you're plugging in null here, right? That the variable value is null. Yes. Now you should have a variable called root that is now pointing to a new node, but you didn't attach it to the previous root that was outside the call stack.
Yeah, I see now.
So this doesn't work.
Yeah.
Okay, so you realize that passing in the node that you want to modify doesn't actually work because it could be passing in null, and you're not able to attach it to the parent. So, what's your next option?
Instead of passing in the node, I should return the no. So I get rid of that. I don't pass that in. Say root equal to that. So we say let root equal that, and then that needs to return. That needs to return null there. So what we need to do here is we just need to say node root equals new node. And then with that, root.value is equal to that, and we set it there. And then root.left is equal to that. Yeah. And then same thing there for right. Yeah, okay. Okay, so yeah, because then if we pass in 0, we return null, so that child is going to get set to null, so that's good. And then if it is null, but there are numbers being passed in, it gets set to a new object right there. So that's good as well. So all it needs to do then is return root. So that way it gets bubbled up. Okay. I think that solves all the issues with all the passing around that we were looking at a second ago. So with that, let's start this test array over again since we changed a bunch of stuff. So we come up here, pass in the numbers, got numbers, make new root, start and end, 0 to 4, middle element is 3, position 2. Technically this middle element index, we'll just leave it there for now. Mm-hmm. So root.value is 3, so now we got 3. And then we slice the left and right arrays. Mm-hmm. Now root.left, which is currently null, gets set equal to this with the left array. So it passes back in with the left array 1 to 2. Middle element is start plus n. So it's, what is it? It's 1 minus 0 plus 0 divided by 2. So we need to actually take the math.ceiling of that. So it gives us the middle element of 2. So 2 gets placed there by that line. And then left array again gets sliced. So that's from 0 to middle element 1 minus 1. So 0, 0, which is just the first element. And then the right array gets sliced again, but that should be nothing. So that's middle element plus 1, which is going to be 2 to input length minus 1, which is also, so 2 to 1. this is okay. This actually confirms what I thought, which is slice is non-inclusive
Okay.
because you would get a length from 2 to 1 instead of just like 2 to 2.
Okay, that's fair. That's fair. But then if you say it's non-inclusive, what else do you need to change?
Then I need to change the that.
Yeah.
Yep. And then so we recurse back in left and sorry, so that's gets put down into 1. So input length, so that's 1 minus, so yeah, end is 0, start is 0, middle element is 0. And then that gets set on the left there to 1.
Okay.
And then, yeah, so that's looking good. And then it returns the 1, so it gets attached to the 2 on that line. And then 2 comes in to here, but it sees that there is no, the right array is blank at this point, so that's fine. And then it returns 2, which gets attached to 3, and we're back up to here again. And now we look on the right side, so this will be 4 comes in, and then gets placed there. And then 4 comes through here. 5 as it's sorry, 4 runs through all this, gets placed again, and then we hit root.left. Does this, so I should have asked this, does this need to be a binary tree or just a generic tree?
Minimum height.
Okay, so it doesn't matter if the greater element's on the left.
It should be proper.
Oh, it should be proper.
Yeah.
Well, dang. I didn't
So-
account for that.
I mean, so what's the quick way to fix this?
Looking back up my old example. The quick way to fix this is if we are placing on the right side, so like if like passing a number like or like a boolean like is left, no, I don't think that's let's see.
There's a go ahead. No, go ahead.
I didn't have anything.
All right, never mind.
Because if we do, so if we go down the right side, we want to say false. True. I don't know if this is gonna work. I'm just testing it really quick.
You don't need that, but you know what? In the interest of time,
Yeah.
I'm gonna straight up. I'm gonna tell. We can stop the problem
Sure.
here. Interest of time. Basically, the answer boiled down to this: you locked yourself into this idea of everything needs to be populated on the left. This is your problem. Literally, just this one decision fucked your entire problem.
Damn.
The reason why, like, you understand why, right?
Because it's always going to take the greater number, regardless of if it's placing left or right.
Yeah, exactly. So it's like, if you didn't do this, then what would have happened is that you would still end up with a valid tree. It just would be like, in the first example, it would just end up in a situation where you have 1 on top and then 2 on the right. Like this. You would end up in this situation, which is still a valid answer. But you locked yourself into basically putting everything on the left. For, I don't know why. It's like, because when you really think about this just boils down to a binary search.
Yeah.
So.
Trying to envision how that runs. This be 3, and then so it takes the middle, and then it would take half, which would just be.
Because start is 0. Start is 0, end is 1. So then 0 plus, 1 minus 0 divided by 2 is equal to 0. So that means that it'll put 1 as the node.
Well, I think JavaScript would actually give you half, and then I don't know what like that would do when you're
It
trying to
should be
grab
0
an
because
element.
you cast it to int.
I don't think JavaScript has int cast. It's like all just number.
Okay. Well, you get a better language then.
Yeah, I already logged into JavaScript with Google, unfortunately.
Right. So either way, point is that yeah, just do it like this. You should have been fine. Either way, I want to talk more about your approach to the problem more than the answer because I think there's a lot that we can work on. So the first one is that I think there's a definite improvement from last week. If we scroll all the way back up and we see your root to leaf, you were eventually able to get the right answer, but you were kind of like meandering about for it. This time you at least were able to get to yeah, let's actually look at the feedbacks. Like why you're writing code, what was the core algorithm? It's like you're writing code, testing while writing, patching, acknowledging the memory limitations, and then you stopped and realized that there were negative numbers, testing again, realizing it, but you're still rushing through it. Second, and then the second problem, not the graph one, but the array problem, it's like it was still more or less kind of the same thing. But then here, I think you made some improvement at least. I would say the biggest one is that you definitely draw it out, which is fine. But then again, you didn't draw this out as a stack trace, and I think that's what that cost you like 10 minutes of your time. So what do I mean by this? What I mean is that remember how in the very beginning you were just like striking out numbers, and then you kind of got lost in got tripped up on your own example.
Yeah.
So what should have happened is that, and let me mark my stuff in red just for the example, is that I would have done this like this. I would have said, okay, well, I know that now that I have this idea in my head, start in the middle of the array, put the left side of the array into the left side, right side of the array on the right side. I understand this is going to resemble a binary search. So in order for me to test this idea, I'm going to start off with the full array. So let's say 2, 4, 6. Let's use your example. 8, 10, 12, 14, 16. I start from here, right? And so I say pick the middle one. So then the next question is, how do I calculate middle? Well then, how do I calculate the middle? Okay, so then the formula for calculating the middle would just be n plus start minus end divided by 2, right? So then here, as if I say I want to pick the middle, then the start is going to be 0, end is going to be, 3, 4, 5, 6, 7, 8, right? 8. So then middle is 4. So what's that element number 4? 10. So
end is 7. Sorry.
So end is 7. Oh yeah. 1, 2, 3, 4, 5, 6. Oh, there's only 7 elements.
No, there's 8 elements.
Okay, so you want what? Okay, fine. All right, n minus. All right, n is 7. Sure, whatever. But I'm pretty. Anyway, so middle is 4. Well, no, there should be 3 here. 0, 1, 2, 3. Then you would have picked 8 as your mid. What are you talking about?
But it's 0 to 7 because there's
0
8.
to 7. Okay, so then 7. So then let's say 0 plus 7 minus end, which. Sorry, that should be end minus start. Oh, sorry. This should be start. My bad. Start. 7 divided by 2. Floor is going to equal to 3. So your middle would be index 3, which is 0, 1,
8.
2, 3, which is 8. 8 would have been your middle.
Yeah. Okay. So the same thing except 4 on the right and 3 on the left instead of what I had, which was
Should have been 8.
the opposite.
Yeah. So, but you get my point here. So it's like, okay, now I know what each variable is going to be. And then end is just the length. End is length of array. And then from there on, so I'm going to split the array into 2, 4, 6, 8. So then left-hand side. And then right-hand side will be, 12, 14, 16, right? And then now I'm going to say recurse into left-hand side. Draw the break. Now I know I'm going in with this again, right? And then pick middle, start 0, end is 4, middle is 2. Same thing, and then etc. etc. See, notice here that I'm actually drawing out step by step, and I can always go back into my previous trace. It's like now that I know I'm done recursing to the left hand side, I can just eliminate that and then just repeat it for the right hand side. So, draw.
Yeah.
I think I wrote this
so
last week. Draw out the stack trace. I'm pretty sure I
Right,
wrote
yeah,
that out.
since- I think maybe you mentioned it. I don't know if we talked about it too much, but yeah. So because you
Wait,
know
you did
it's
it
gonna
last week.
Did I?
Yeah, I like how you're testing and showing the stack trace, but I have no idea what you're thinking. So I want you to do it like this. This will help organize your thinking, and it will shave off like a good amount of time.
Okay.
So this is the first thing. Be able to draw this stack trace. Trace will help you a lot. It'll help you a lot. The next thing is going to be you're skipping out a little bit of details. Like you kind of started the pseudocode, but then it's like, yeah, like how do you calculate your middle? What is your end? So the moment you saw me do this, we could actually test like what we wanted. You know? Like the moment we actually we put like hard values to it, it's like if I say I'm picking the middle, how do I calculate the middle? Does that make sense?
Yeah.
So these are the little details that we go through. If you have a step and it's like, oh, you say put middle, how do I calculate it? You know, like all these little, like these hand wavy things. Be aware of that. That what you're hand waving, what you're not. Next thing is that you should recognize that this boils down to a binary search immediately. And it's like from there on, that should have been like, you should have modeled it as a binary search, except that, you know, when you go to the left, you just recurse into an array. You just do a recursion. So, and had I done this, I wouldn't have split the array. Actually, I just did this as illustration purposes. I would have recognized, you know, start, end, and move the pointers. But that's all. That's really minor.
Yeah. Either way, I guess.
Yeah, either way, it would still work. So yeah, like also the language thing, kind of hurt you again. And also this little spiel with the, oh yeah, let me pass in the node versus creating the node. That tells me that you are very weak with recursion.
Yeah.
Yeah. So
definitely
pass in node versus you know, create the node. The reason why is that because from my perspective, I'm like, if I go back to the pseudocode, I'm saying I split the array, because split the array, you know, recurse left, get back the node. Because when I go to create the node assign value, my left hand side and right hand side are by null default, you know? And you know, maybe there's a valid case where this can be null, you know? Because this could be null. So that is a valid case. And when I initialize node, it's going to be that way. So what benefit do I get by passing in null? I need to attach a child. So in other words, if you thought a little bit more about that, you would have realized, hey, wait a minute, I need to get back a child node to attach. It's like just taking that little extra step. What is the consequence? And I think that goes back to like the pseudocode. I think like you were kind of you getting the pattern, you're getting the gist of it, but you needed to put like the hard details to it, where the rubber meets the road. And once you did that, I think you would have understood what needed to happen. And again, like this thing right here, so you skipped some steps again. Like I can do this because I'm kind of aware of it, but even then, I would recognize what I need to return back. What do I need to do? What do I need to get back from this? Well, again, if it's void, then I have done nothing. You know. So after I get done with this function call, I need to get back something, or maybe I don't. And this is where I would have done the determination. Instead, it's like because you skipped the steps of properly returning what you needed, you messed up here. So literally, just because you skipped that one detail, in the stack trace, instead of doing the example, instead you were just like kind of walking through it, instead of picking up on every single little detail that you needed to, that it hurt you later on. That's really all that this boils down to, is the fact that you just weren't atomic with the example. Does that make sense?
Yeah, I just didn't like I just did I did the problem, but I didn't like think about the actual like implementation of the problem.
Yeah, that's the thing. Like you understood the pattern. I think that's fine for you to get the gist of it. I would have liked for you to walk through it one more time, and for like, or at least, you know, combine like your intuition with what really needs to happen here. And by simulating the stack trace like this, I think you'll get a lot of value out of that. You'll be able to see exactly what you need on the left hand side, what you need on the right hand side, what exactly you need, and what you need to return back. That should define your function. That should help mold your pseudocode, and that should tell you, hey, wait a minute, what happens at each step? You know, like, and if I want to be really complete, I could just say pick middle is 10. So create node, value equal to 10, left node dot left is null, node dot right is null. So I need to realize that recursion on the left hand side, and let's say we skipped the steps and went back, then attach node dot left to be return value. You know? And then that would just go down here into the pseudocode, and then you could just update this to be node of was it 6 or 4? Yeah, you get the idea.
Yeah.
So this would have helped you, and I think like that way you could have at least seen the progression of the code. You could have seen like what the objects were being created and how each step plays into each other. So that is the big takeaway I think for you compared to last week. Let's do the notes from last week. Before you weren't even really doing this. Now at least you're kind of doing it, but then it's like you need to be a little bit more atomic about your details. And I think you kind of do it here, or at least or maybe I did it as well, where I wrote out the values for them.
Yeah, it's kind of like a skeleton of doing it. It's like I'm writing it, but I'm not actually like doing the work to really like define the solution.
Yeah, I mean at least you're doing it. That's at least the basic part. But then after that, you need to be able to. Yeah, I'm going to paste you my notes from the timestamps. Yeah, but you need to write the damn values. You need to write the stack trace. So I'm going to give you the next problem, but I want you to be able to do it in the way I just showed you. Does that make sense?
Yeah.
Because again, like the whole thing here, this whole episode came about because you attached some random fucking thing to ceiling that you didn't really, you could have easily avoided had you just done it at the very beginning. That way you didn't have to run through like 2-3 times.
Right.
Okay, so, yeah, let's drill your recursion right now. I think that's the best thing I can do. Yeah, sorry, give me a sec. I picked out some different problems, but yeah, I needed to find one. No, not this one, not this one. Nope, that's not it. Did we do the height balanced? Did we do the height balanced?
Is that the one we just did?
No, this one is to build a minimum height tree. I want you to see if a binary tree is height balanced.
Okay, no, we didn't do that.
Okay, so yeah, this time I'm not going to time you. What's important is that you actually do the stack trace. Okay.
Yeah.
And I want to see, and I want you to be able to observe the difference. So okay, so I want you to test to see if a tree is height balanced. So what do I mean by height balanced? Here's your parameters. An empty tree is height balanced. A non-empty binary tree is going to be balanced if the left subtree is height balanced, the right subtree is balanced, and the difference between the height of the left subtree and the right subtree is not more than 1. Does it make sense?
Yes.
So, do you need an example or are you good?
If you have one, I'll take it. But I was going to draw out my own example or two.
Sure. Yeah. Let me send you one. So this would be an example of a height balanced tree. Notice that at each node, the left subtree differs no more than the right subtree by 1.
Right. Got it.
Okay.
So then let's picture. There we go. let's just take a super simple example. Let me just copy the one from earlier because that'll just be a good example, I think. There we go. Okay, so according to this example is a height balance tree because the left side is only one greater than the right side. So the right side, if we do like 0, then this would be at level 0. This would be level 1. This is 2. And then this is 3. So basically what we want to say is if left height left height minus right height, we want to take the absolute value of that just in case it's the right side that's greater, is greater than 1. So we actually want to return the inverse of that.
Wait, what do you mean greater than 1? Is that if it's balanced or imbalanced?
So this is going to say if this is true, if the absolute value of the left height minus the right height is greater than 1, then it's imbalanced.
Okay.
So, I mean, we can complicate this and make it with some knots and whatnot, but that's fine. We'll just leave it right there for now. If true, is imbalanced. So what I'm thinking right now is we can do a DFS and save the height and pass it around throughout the DFS call.
Okay.
So basically, we'll start at 10.
Okay.
So we will be pass in the.
I would build up instead of build down, just for the sake of sanity. Because
Okay.
Stack, push, pop. It's easier to do it from the top. So.
Okay.
Yeah. So just instead of putting the line underneath it, just put on. So start with 10, and then up here, what do you want to do?
Okay, I see what you mean. Sure. So we'll start with 10. Then we will basically. So for every DFS call, we want to pass in the height of the previous node.
Why? Do you know the height of this node right now?
So we're going to start by passing in 0.
Okay.
So basically, you're gonna pass in 0.
Okay.
And then when you get
Well, you're passing it in. What do you intend to do with it? Let's talk that out first.
So I want to increment the height.
Okay. But
By
you're
1.
passing it in. It's not passed. An integer is not going to be passed by reference.
Yeah, so it's got to return the height as well. Basically, it's got to return the height of the node that you're at.
Okay.
So I'm losing my train of thought. So okay, let's start by saying what our base case is. I think that'll be a better start.
Okay. What's your base case?
Base case is if root is null.
Okay.
Return.
Return what?
Null, void.
Why? What's the answer?
Because
what's the question asked for?
If the tree is balanced.
Okay. Is null a valid answer to that?
I guess okay. So no, we would return the we'd return in the passed in height value because it wouldn't have been changed at this point.
Why? If I ask you if a tree is height balanced, you're not going to answer 3 to me. It's a simple yes or no question, right? Is a tree height balanced? And so
Yeah,
what? So what data? What type of variable can represent yes or no?
I mean, a boolean, but we
Yeah,
have to.
There you go. So you know you need
We
to
have to
return a
get
boolean to me. Like what
Okay.
else are you going to return to me that is going to that is what else are you going to return to me?
I mean, I got to get the numbers to make sure that they're balanced.
That's an implementation of the question. That's not the question itself. Remember our base case. If I gave you a root, if I gave you a null node, you're not going to return back 5, 10 as the answer if I ask you if a null node is height balanced.
But I'm not going to return true or false because I don't know anything at that node.
What do you mean? It's a base case. It's like if I ask you, do you live in this apartment, and you answered me fish, or you answered me luggage. It's like I don't know if I live there unless I have luggage. You know that's not an answer. It's like it's a simple yes or no question. It's a very simple thing here, and I think this is part of what you're doing. You're overcomplicating it. Again, if I asked if a single let's change it from null. Let's say that I gave you a single node in a tree, on its own, no children, a leaf. Is that height balanced?
Yes.
So what are you going to do in that case? Are you going to return back to me the height of it?
So, I mean, at some point we have to recurse down through the tree, and I wanted to check the two values of left and right at that point.
Okay, sure. You can check left and right. You can check whatever the hell you want. But again, we need to answer the fundamental question. If something is height balanced, 3 is not an answer to a yes or no question. Would you
Right, but
agree
I haven't gotten to the point where you say, does left equal right?
Yeah, you haven't even gotten to that point yet because we're still dealing with the base case. We're still trying to match what the heck we're working with here. And you're skipping straight ahead to the implementation. Because the question that you're asking right now is a question of how do I implement my algorithm? We're just answering, is this what we're looking at? Is a simple node, yes or no, height balanced? Like you said, we're starting at the base case. Right? Do you understand what I'm trying to get at here?
I don't know if starting at the base case is good or bad based on what you've just said.
Well, with recursion, there's always two cases, right? There's always the recursive case, or cases, and the base case, right?
Right.
The base case tells you at what point can you be absolutely certain there is no room for doubt. You don't need to go any further. You can stop right here, right? Like the Fibonacci sequence. Let's take a very basic example of Fibonacci. So what's the Fibonacci sequence of like starting at 10, or let's say 5. So it's 5 plus 4 plus 3 plus 2 plus 1. Now I know I can stop at 1 because I know that. Yeah, wait, do I? Or factorial? Sorry, let's do factorial. Factorial, right? So would be just factorial of 5 would be 5 times 4 times 3 times 2 times 1, right? 1 is my base case because I know if I go 1, then if 1, then just return 1. I don't need to go any further than this. Or maybe I can go, or maybe if I don't have that base case, then I go 0, -1, -2, or however you tell me, whenever you tell me when to stop, right? Correct?
Yeah.
And so this is our stop case. This is our stop. So the question is, what is our stop when it comes to this tree? Like, we're going to traverse the tree, right? So the question is, when do we stop? And when we stop, what is the question that we want to answer? Like, what's the answer? Does that make sense?
Yeah, so, I mean, the answer is, what is the depth of the node?
Okay, I mean, that does play a part, but right now we're just handling what happens if the root is null.
So what I'm thinking is before we even get to is root null, we should just make the base case is left and right null.
Is root null not a base case?
Yes, but you don't
But
count
what?
the height of the null node.
What are you talking about?
If it's null, why would you count the height?
There's nothing to do with the height. The question is whether or not it's height balanced. Right?
But how do you know if you're at 2, how do you know the tree is height balanced? How can you say yes?
We're still dealing
or
with
no?
null. What are you talking about? We're still dealing with this question. What if null? Yes or no? What do you mean 2?
Like if you're on left of 2, you're here. How can you say yes or no at this point?
That's up to you. What do you want to say?
False, I guess, but
Okay. So you want to return false if there's no tree. Okay, so you decide that this is null. No, right?
yeah.
Okay. Okay, that's fine. Okay, let's say that is the case. All right, so let's go to like a single node, right? Node. Let's just take 2 by itself. What's your algorithm and how you're gonna do it? Is 2 by itself a height balanced tree?
Yes, it is.
Yeah. Okay. So if it's single node by itself with no children, return yes. Okay. Now we're starting to get somewhere. Now what happens if I attach a child to it? Like just one child. So is this height balanced? It's not balanced. Why?
Or no, it is actually. Yeah, it is.
Okay. You start to see where I'm going at with? Where does height play into this?
But I mean, like, if this is 3 and that's 4.
Okay, let's draw it a little bit back. You're jumping ahead again. So let's say you're at null, right? You say the answer to this is yes, right? Why?
Because left is 2 and right, or left would be, if we're starting at 0, left is 1 and right is 0, so it'd be no difference greater than 0.
No,
1.
Here's the reason why. Look, your left child, by your previous case with a single node of definition, is yes, right? Your right child is null, so you said no. And what did we say with the definition? If we go back to the definition, let me copy paste it for you. The left subtree is balanced, the right subtree has to be balanced. You just said that the left subtree is balanced, but the right subtree is not. Do you understand what the problem is here?
I can't get past how we're supposed to figure out what 3 is.
We haven't even gotten there yet. We have not even gotten there. We're still dealing with this case right here. We're still seeing this. We haven't even gotten to this yet. This is not even a factor. Right now, we're just still dealing with the left subtree and the right subtree. And based on what you just told me, it is not, because you made this base case root equals null. No. Does this make sense?
Yeah. But at some point.
Where does height play into this? Tell me.
Because, like, if you just go one more number down on the left, it's not balanced anymore. But if it's null on the right, you're still going to return true. And now you're just saying, like, is true equal to true?
Yeah, it's true equal to true.
But it's not, because you're going down 2 more. You're going down 2 on the left and none on the right.
Wait, so you're saying you're counting the nulls now? We're still dealing with this example right now. We haven't gotten any past anything else yet. We're still dealing with the very basic cases. All we've done is introduce a node that is with no children and a null node. This is all we're working with right now.
Okay, in this case, then yes, true in this case.
Well, then what needs to change in order for this to work?
In order to work with like a different example, or to work
No,
with this
by the
example?
definition of a height balanced tree. Because you just said this when a node is null, it is not height balanced.
I'm saying based on the example you're telling me now, it's got to return true if it's null.
Right, so which means
That it returns true.
yeah,
Return true.
exactly. Does that make sense?
In this case, yes.
So, in other words, yeah, so the moment we start building it up, we haven't even gotten to anything complicated. All we're dealing with is just a node with one child. We haven't even gotten to any of the complicated shit. Does that make sense? So, and this is what I mean by you jumping the gun. You're talking about heights, you're talking about like all this other stuff, but we haven't even solved the very basic case of where we terminate. This is what I mean by when I say to build things from the ground up. Be able to understand what exactly you're working with, and you're jumping the gun with like just this height and shit. Like we're just trying to satisfy this first two definitions. Like, then the third one, then we can deal with the third one. We haven't even gotten past the first two. I know I'm being harsh here, but I'm really trying to drill this in your head. You're jumping steps.
Yeah. No, you're fine. Some trees balanced. I can't picture a scenario where you can fulfill 1 and 2 and also 3 though. That's where I'm getting hung up.
Where you're thinking 1, 2, and 3? Okay, perfect. Yeah. Now you understand. You understand where your confusion is. The moment you start breaking things down, now you can clearly state where your confusion is. That you cannot think of an example where 1, 2, and 3 all collide. So, let's actually try to do that. Can we think of a situation where left subtree and right subtree, and you know what, just for the sake of time, I'm going to actually tell you that this is possible. Why? Let's pick up a tree, right? 2, 1, right? This is height balanced, based on what we talked about, right?
Yep.
2. This is no longer height balanced, right?
Nope.
But what if I added, 5? Let's say I added this. This is now height balanced, right?
Yes.
You would agree left is height balanced, right is height balanced. What happens if I add them together? What happens now?
They're not height balanced.
But the left subtree is height balanced. The right subtree is height balanced. But number 3 doesn't work. Do you understand what I'm getting at now?
Wait, where'd the 2 on the right come from?
Sorry, I'll use real examples here. 3, 5, 2, 1, and then 12. I'm just positing this as a hypothetical example.
Okay.
Now, like you said, this left subtree, if we eliminate the 10 and 12, you can see that the 3, 2, 1, 5 is height balanced. You said this.
Yep.
The right one is height balanced because, again, a node on its own, our base case, a single node with no children, is height balanced.
Yes.
Therefore, 10 is like, but when we combine them together, number 3 gets violated. Now,
Yes.
Why did I harp on the base case? What happens if I change this 12 to a null? Like, yeah, you might, that's why doing this first, like all this together, obscures it because it doesn't matter if null was true or false. Like, because overall, this whole situation is different. You know, it's like it doesn't matter whether this comes into play because number 3 is violated either way. That's why I'm saying that it doesn't matter what the height is right now. You need to focus on the very base case, which is the left subtree, right subtree, and then like the difference. So so start with a very basic node. Start with those base cases. Do you need like 5 minutes to digest this?
I fully understand 1 and 2, but 3 is really where I'm falling apart.
Okay, what is it about 3 that you don't get?
Because you're going to return true on the left, you're going to return true on the right.
Okay.
You're going to come back up to 10 and you're going to say true, true, but it should be false.
Well, we said that this is was a height. Was this is balanced? Yes. Let me do this. Left, height balanced. Yes. Height is 3. Right. Height balanced. Yes. Height is 1. You get the pic? Does this make sense now?
Yeah, so the part I was trying to figure out is how do you get the height back so you can compare the heights.
Mm-hmm. Yeah, this is what now you are in a position to do that. Do you understand? Now that you've answered 1 and 2, now you can get to 3.
Okay.
So, yes, you are right. Now that you saw that, you saw this example, you realized, hey, now I need to have the heights returned back to me. But do you remember what you said before? You said you needed to pass the heights in.
You return the heights back. But how do you know what height you're at if you don't pass in the height you're at?
How do you know what height you're at a 10? Like, if I just start my traversal, how do I know what height I am at 10?
Because you're starting at the root.
Okay, so what does that tell me? That my height is 15? 10? 5? How do you know this ahead of time?
Well, because the root's at 0, right?
Okay, sure, you can use root 0. Okay, so if you want to count it that way, go ahead. What's next?
So, I mean, that's when you... So, I mean, you have to increment the height for every level you go down.
Okay. You could do that. What else could you do? Doesn't that get fantastically complicated? Because every level you go down, you have to start incrementing everything on above it. Like, say I go down the left side, right? I pass in my 0 to 3, right? Now at I'm 3, where am I? 1?
Yeah.
Okay, so now I'm at 1. Now, what values am I passing down? Am I still passing down this height? This? Or am I passing down both of them?
No, you're just passing down 1.
Okay, so now you're at 2. Okay, and then now I'm passing down 3.
Yeah, so then it goes to 3, and then you return the height, and then at each level you take the maximum height of the left and right.
Okay, so you're gonna pass in 3 here, right? Because you said you're gonna return back 3. So now.
Yeah, so 3 comes back up.
Okay. So why do you need to pass it in? Why can't you just start from 0, 1, 2, 3?
Oh, and just increment it every time you come back up.
Mm-hmm. What value does it give you when you just start at 0? When you start at 0 and it pass that in?
I mean, it's nothing. It's just 2 different ways of doing it.
Mm-hmm. But the thing is that it got overly complicated. There's no value in throwing it in and throwing it back up. And the reason why I'm just really harping on this is because it overcomplicates your problem and you're focusing on the wrong things. Does that make sense?
Yeah, but there's like no chance I would have come up with doing it bottom up on my own.
Mm-hmm. But that's why I'm really forcing you to do it bottom up. That's the whole point. That's the whole reason why you're here.
Right. Yeah. Yeah.
So now that we've removed all the complications, and you decided, or I don't know if you still want to go with the passing in method. It's up to you. Where do you want to go from here?
I mean, we've talked about it so much I could probably just code it right now, but I don't know if there's any point in continuing this at this point, because really we've gone over every situation that you don't even have to like write out any more examples really.
The whole point of getting in here was for you to do the stack trace. So I want you to do the stack trace for this. You might understand it, sure, fine. I want you to walk through it as if you were trying to demonstrate it to me. I want you to do the stack trace that we did before.
Okay. So we come in at 10.
Okay.
Traverse left to 3.
Okay.
Traverse left to 2.
Mm-hmm.
Traverse left to 1. Can't go left or right from 1.
Mm-hmm. What do you need to return?
We need to return the current height.
Okay. What's the current height?
So at this point, the current height would be, I mean, it's 0. So we would return 0 plus, no, see, this is where I'm getting confused. This is why I would have to pass it down, because where does it come from otherwise?
Well, what's the height of a single node?
0.
A height of a single node is 0?
Okay, I guess this makes more sense to make it 1 based and not 0 based.
Okay. So you return 1. Now what?
Return 1. So from there, pop up to 2.
Okay.
Left height.
So I would recommend. So when you do this, I would recommend. Sorry, I'm going to stop here. So 10. You see, you traverse to 3. Traverse to 2. Traverse to 1. Can't go right. Needs to return 1. Okay. So you got the value of traverse to 1. Traverse to 1. So now you come back out with a result is 1. And I would just erase the stack trace here. Okay. So you traversed to 2, traverse to 1. So now that you traverse to 1. So this is node 2, by the way. And then this would be node 3. Okay. The result is 1 on left-hand side. Okay. Now what?
So check node right of 2.
Okay.
It's null.
Okay. So what is so it's null. What is the result of a null?
0.
Okay, sure.
Or, yeah, 0.
Okay, sure. So what are you going to write?
Return 0.
Okay. And then now you return 0. You pop back out of the stack. What are you going to do?
Take max of left.
Well, you need to record it first, right? This is what I'm talking about, stepping steps. Result is 0 on right-hand side. Write out. Remember, write out each step. Okay, so you see result is 1 on left hand side, result is 0 on right hand side. Now what?
So now we take max of left hand side and right hand side.
Okay.
And then turn max.
Okay.
So now we're at where did we were at 1 and we're back up to 2, so now we're back up to 3.
Okay. So then you can eliminate the stack trace here, or you can just strike it out. I'll strike it out for you. Okay. So then here.
Oh, you're okay. I understand now what's happening.
Yep. So let me format the text. So traverse left to 2. So the result is what you said 1 on left hand side. Okay.
Yep. Traverse. Oops.
Yeah. It's...
traverse right to 5.
Okay. So now you traverse right to 5. What? Yep. Okay. Let me put some lines in between that so the strike through doesn't bother you. So go ahead.
Yep. So traverse right to 5. Then we say check left, return 0.
Okay.
Because it's null.
Okay.
Same thing for the right.
Don't skip steps. I still want you to write it, even though it's pretty obvious. I still want you to write it.
Okay.
So
then.
Yeah. So node 5, check left, turn 0 is null. So then, what do you want to write?
So then I want to write that the left-hand side result is 0.
Okay.
And then now I want to check right.
Mm-hmm.
Return 0.
Mm-hmm.
Because it's null.
Mm-hmm.
Right-hand side result is 0.
Okay.
And then I want to return wait.
What you said you want to take the max to the left hand, right hand side, right?
Yeah, but it would be 1 plus the max of the left and the right hand side.
Okay. So then what happens here? What happens on the left hand side? Remember, because before you just took the max. So how does that affect what you've done before?
What I did before was wrong.
Okay. So then update it.
Yeah, so this is on 3. When we traverse down, we return the max of left and right on 2, which is 1, but we didn't add 1 to account for 2, so the result should have been 2.
Okay. Right now, I'm not caring about whether or not your answer is right or wrong. I just want you to walk through this exercise.
Okay, so now we traverse right to 5, and we check to the left, it's 0, check to the right, it's 0, and we return the max of left and right plus 1.
Okay. Which is?
Which is 1.
Okay, cool. Now what do you do?
So now we're back down here
at
node 3. And we are going to say result is 1 on right hand side.
Okay.
And then we want to return max of right hand side and left hand side, which is equal to
you forgot something.
I was about to write it after that, but yeah, it makes sense.
Yeah, I still want you to be very atomic about it. This is what I mean by details. Don't skip them.
Yeah, so plus 1, which turns into 2 plus 1, which equals 3.
Okay, cool. Now what?
So now we pop back up to 10. So we're back up here to 10. Left hand side is equal to 3.
Okay.
Now we traverse right to, what is the number? No.
Okay.
Traverse right to null. Returns 0 because it's null.
Okay.
Base case.
Mm-hmm.
Right hand side is equal to 0.
Mm-hmm.
Okay, so at this point, we need to do some sort of comparison, but that isn't what we were doing before, so...
Okay. What do you want to
Because
do?
what's gonna... So let me write... This would return max of left-hand side, right-hand side,
Mm-hmm.
plus 1, which is going to be 3 plus 1, which is going to be 4, but that doesn't tell us anything.
Mm-hmm. So what do you need to do?
So we need to... So we need to compare left hand and right hand, obviously, but what I'm trying to figure out is how do we do that if this recursive function wasn't doing that
Mm-hmm.
at any other point?
Okay.
So I guess this is where my brain was at the very start, is where we've gotten to now.
Okay. Don't worry, I'll tell you why. I'll tell you why I made you do this, and I'll tell you what the shortcomings are. So don't worry.
Yeah, because now what I'm trying to figure out now is like this is what I wanted to do at the start, which was return the heights.
Okay. And I'm telling you, and going back to it, I'm telling you that that's not enough.
Yeah, because we need to somehow compare them, which is what I hadn't figured out yet.
What else do we need to do? It's in the definition. Scroll up. It's the thing I spent like basically 10 minutes yelling at you about.
Yeah, so...
You need to see if left subtree and right subtree are height balanced. And this is what I'm talking about. You're tunneling. You're like focusing on the wrong thing. You're talking about just one thing. Well, you have two others that are very basic that you should be dealing with. So, how do you want to do this?
Zero. Oh god, how do we compare? We would have to return the left and right values and let... No. That's what we're already doing.
You're already returning back the heights. What else can you do?
So, I mean, we got to compare them, obviously, but, like, am I supposed to return, like, a tuple? That doesn't make any sense.
Why not?
I guess I just wouldn't expect a problem to want me to return a tuple. It's very rare that they ever get used.
I mean, isn't this a situation where it gets used? Literally, the question we asked you, is it height balanced and the height? This right here. I pretty much kind of gave it away when I said, hey, yeah, you want to do a height balanced and height, so you kind of need to return two values.
Yeah.
And this is what I'm talking about. Like, you need to, like, being able to satisfy this definition. So, and if you just took it organically from what you needed, it would be a whole lot easier. Does that make sense?
Is returning a tuple really the right answer?
I mean, what else do you want to do?
I usually just refactor code that returns tuples to not return tuples. I've
Okay.
learned to not.
So
use
so
that.
then how do you want to refactor this?
I would create a class that has both the height values, and then it would set the true or false there, and then you would return the class up through the stack.
Okay, that's fine, but it fundamentally doesn't change anything, right?
No, it just hides the tuple.
Yeah, I have no problem with you packaging it nicely. That's fine, but it's a cosmetic change on top of what actually needs to be done.
Yeah, so I mean, instead of returning just max left right, you'd also include like what was it that I wrote earlier? Return the absolute value of left and right greater than 1.
Now, you said left, right, plus 1? Yeah, you need to do that comparison as well. Okay.
It actually, technically, if we want to, it'd be not, because we want to say if it is greater than 1, then it is not balanced. I'd rather say like is true balanced. So
Sure. So then what? So then now that you know you need to do this condition, now you need to know that you need to return this stuff. How does that change what you need to do?
So I mean, instead of just returning max, we have to like package it in a little tuple array or something.
Mm-hmm. Why not? Yeah. Okay, so you said return back the height, and you return back of his balance. Okay, so now that you have that, what else do you need to do?
Yeah, so now we need to say
keep in mind this is not completely correct either, but because there's other. Remember the definition. What did I just tell you about?
it's gotta be, where does it go? It's gotta left and right has to be balanced.
And
The difference has to be not more than 1.
right, so you have 3 conditions you need to meet.
So left, so the left and right balance gets covered by this.
Really? Do you remember the example I just showed you? I mean, yeah, I mean, you could use that, but what I had, let me just, for the sake of time, let me tell you what exactly I was thinking. So,
Sure.
So yeah, the tuple is going to be fine. What else? But you also need to consider the results. Let's call your function foo, or let's call it your function result actually. So what would have happened is that you would have needed to do a node equals null. I'm going to start from the beginning. So this is your base cases, right? Node equals null, return true, as we discussed, right? So then now you need to get the height, right? So let's just say this is left-hand side equals to result of node.left. Right-hand side equals to result node.right, right? So we know this left-hand side and right-hand side is going to be a tuple with some shit in it. So the question, so then we need, what's it called? Your calculation here.
Don't you have to return a tuple here then?
Yeah, you're right. Good point. So then we'll return true, and then a height of 0 or whatever. Right? Or actually 1. 1 or 0. One of them. I don't. Okay, so yeah, no, 0, 0. It's gonna be 0. So because otherwise the single node will become a 2. So yeah, it's gonna be 0. So here, let's say left hand height. Well, left height is gonna be left hand side dot height, right? and then right height is going to be equals to right hand side dot height. And then here we also have our two other conditions, right? And left hand side dot is balanced, and right hand side dot is balanced. Then we can return true, tuple true, comma then the height of whatever this is. So it's 1 plus max of left height right height. Otherwise, return false, false, minus 1. Now let's refactor this. How's that look to you?
So command. Node is equal to not true, yeah. Inside. Yep.
Do you understand where we're coming from?
With regards to
how we came to this answer?
I think so, yeah.
What do you mean you think? I need to know, like, if you get it or you don't. There's no in between.
So I mean, we had to return the height and if the tree was balanced in order to fill both cases. Whereas I was really only focused on returning the height to fulfill one of the cases and didn't think about how to fill the balance cases.
Because you made the assumption that, oh, if we fulfill the third condition, then the first and second are automatically fulfilled. And I mean, but you should be thinking, there's a reason why I gave you all three of these conditions. And then I literally plopped an example in front of you.
Right. Yep.
So, yeah. So this is what I'm talking about, like skipping steps. I think you're getting a grasp on how to do the stack trace. But in general, you should be like pretty detailed about the values. So in other words, you should know what the like when you return back the height, you should assign the value. You should check. You should also be saying, oh, left hand side dot balanced is da 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 da. But I think you understand at least the basics of the stack trace, correct?
Yeah, that part I get that part.
How do you feel about doing the stack trace?
Well, now that I understand like how you want to see it, I feel fine with it.
You feel fine with it?
I think so.
Okay. If you feel fine with it, then I want you to run through this code right here using that stack trace.
And I'm going to just like erase this one and start over. Or...
I want you to start over. We're going to do the exact same example that I put up here. We're going to do this one. And I want you just to do it how you think would be the best.
Okay. Okay, so we will say node 10. Then we will say traverse left.
Okay, node 10.
That brings us to node 3.
Okay. I do want you to also mention the node equals null comparison. Just at least, or if you don't write it, at least verbally say it.
Okay, so we start at node 10. It's not null, so we begin traversing down to the left.
Okay.
And we traverse to node 3, which also isn't null, so we go left again.
Okay.
So we're going to keep going left until we hit our base case, which is the node being null.
Okay.
So that brings us to node 2,
Mhm.
which is a null. And
Mhm.
so we traverse left again,
Okay.
which brings us to node 1.
Mhm.
So now we're at node 1. We that's not null, so we traverse left.
Mhm.
Uh, but it's null, so it returns.
I would so quick thing. I would still try to
You-
do create the stack
still
trace
go
for.
into
I would still try to do
stack.
this. You know,
Okay,
just as a formality.
sure.
No. So you gotta recognize it.
No null.
Mhm.
Base case, return true 1 or 0. Sorry,
Okay.
true 0.
Okay.
So then we come back down into this call, and we say left-hand side is equal to true 0.
Mhm.
Now I guess we can just erase this. Yep.
Mhm.
Traverse right.
Mhm.
Node is null.
Okay.
Return true 0.
Mhm.
So now we say right hand side is equal to true 0.
Mhm.
So now at this point, we look at the code up top, and we say compare the absolute value
Mhm.
of right hand side height
Mhm.
and left hand side height,
Mhm.
which is less than or equal to 1.
Mhm. Okay.
Tells us if balanced.
Okay. Sure. So what are the values?
So that's going to be 0, 0.
Mhm.
So we take the 0, which equals 0, less than or equal to 1, which is true.
Mhm.
So we'll just
Okay.
it's true.
Sure. You don't have to be that detailed, but I get your point. Yeah.
Yeah. Okay. So if the do we actually need these right here if we're comparing?
Okay. I mean, you might as well just write out. You might as well write it out.
Okay. So if left and right are balanced, return true
Mhm.
1 plus max left height right height.
Mhm. Yep.
Else
I mean, you don't need to
return-
be that. You don't need to be that detailed, but sure. I'm gonna give you a little bit of quick hand. You could just verbally tell me if left and right hand are balanced, return 1 plus max left right. I mean, you could just substitute these with the values if you really want to. Cause you could just, you know what I mean?
Okay.
I'm gonna give you a
So
little bit of a shortcut, but yeah, I mean, in general, you should practice this. But I'm gonna speed it up just for the sake of time. But what you're doing is
Okay.
correct.
Okay, so that was at node 1.
Okay.
So we return the true, 1 plus max 0.
Okay.
So now we come back up down to node 2 and we
Mhm.
say left hand side is equal to true 1.
Okay.
And all this goes away.
Cool.
So now we traverse right.
Okay.
Node null,
Mhm.
because the node right of 2 is null. Return true 0.
Mhm.
So we say right hand side is equal to true 0. And then same as before, we say if absolute value of 1 minus 0 is less than or equal to 1, and left/right balanced, return the true 1 plus max of 0, which is 2. So then at this point, we're back down to node 3. Left-hand side is equal to true 2.
Mm-hmm.
That goes away.
Okay.
So then we traverse right. We're at node 5.
Mm-hmm.
We say traverse left. In the interest of time, I'm not going to write out the 2 null cases for left and right of 5.
Fine.
Left-hand side is equal to true 0.
Mm-hmm.
Right-hand side is equal to true 0.
Mm-hmm.
We're going to return the absolute value of 0 minus 0 less than or equal to 1, and left/right are balanced, which is going to be equal to true, comma, or sorry, it would be a max, sorry, equals return max of 1, no, 0, 0, plus 1. Plus 1.
Okay.
True, comma.
This is what I mean.
Okay.
This is why it's important to write it all out, but you get the idea.
Yep.
Okay. So,
I
mean, we still have like
keep
8,
going.
Yeah, we still have 8 minutes left. I think you get the point of what I'm trying to convey here today. I think you have a lot here. So let's actually do a quick recap, and then I'll give you some pointers here. So the first thing we talked about was you need to be able to get to write the values, write the details of what you're doing, and this is what we spent basically the majority of the coaching session on, being able to make sure that you understand what you're working with when it comes to recursion. You're basically going back up to the problem. I basically showed you the clean way of going through the stack trace, or at least a partial version of it. I do have a video on drawing the stack trace out, and I highly recommend you watch it, and everyone else in the stream as well. And where you tell me very explicitly what the values are, you tell me what you're doing, what you expect to return back, and so on and so forth. And then we went to here, and then I kept trying to harp on you for not jumping into this. Because again, the crux of the issue was that you couldn't imagine a scenario or an example. But the thing is that there's a reason why people actually say the definitions that they do. You assumed that if you satisfied 3, that you couldn't satisfy, that you automatically satisfied 1 and 2. And then, of course, I kind of showed you here that was not necessarily the case. And then also, there's also another case as well here, where if I were, gave you something super skinny and long, well, technically these two would be balanced from the perspective of 10, but then each of these are not locally balanced as well. So this is where I'm talking about, this is where like generating the right examples would have helped, understanding why these conditions are needed. So in other words, this just becomes a logic puzzle. So it's like, okay, what's an example of where a left subtree is not height balanced, a right subtree is balanced, and the difference between the heights is not more than 1, And this just becomes a logic puzzle, like a logic combinatorics. So in this case, I've already shown you that the left subtree and right subtree are not balanced. I can always expand this to be, so right subtree is balanced, but the left subtree is not balanced. From the perspective of 10, the difference between the heights and lefts of subtree is not more than 1, because the height of this is 3, the height of this is 2. So, and I've just shown you that this is not a height balanced tree. So this is literally, this just comes down to being able to recognize how the relationship between the problem statement and the recursion that you're doing. So, going back to this, I basically made you recognize what your base cases are, because it's very important for your recursion. You don't know when to stop, and you don't know when to continue. So this is what happened here. Then you realize when you actually had to look at this, you realized you needed to come back with a tuple, but then you were resistant to it because you we're thinking to refactor it, but again, it doesn't fundamentally change what you need to do, because if you walk through the example, you realize, wait a minute, I need to be able to return these two values in some way. And once you realize that you need to return the values in some way, and I mean, that sounds perfectly reasonable, that should have automatically forced you into picking a tuple or a object or whatever the hell you want in order to make this happen. Now, that being said, now that you had figured that out, we came up with this code here, and then from there on, you were able to do the stack trace. Now, the stack trace is something I'm going to recommend for your homework. So, homework. 1. Draw out the stack trace. Keep going what you're doing from before. Value, like, write the... Don't skip details. Don't skip details. Write out the values. The second one. And so I'm going to scroll back really quickly to see if I mentioned anything before from the previous session. Okay, so at least you have an idea of what at least you're able to explain what you're thinking. Create an algorithm. No, I skipped that one. Yeah, write out your steps. Yeah. Yeah, so write out the steps that you're going to do again. 2. Write out the steps you want to do. And this kind of goes hand in hand with that one. 3. Understand the relationship between base case, recurse case, recursion. Seriously. Drill recursion. This should become automatic. Like, it should be set up like function, and then base case, recursive case, operation, recursive case. It should be automatic like this. Done, done, done. And then because you still have some issues with like passing in values. Why? And then, like, that was what happened with like the first problem and the second problem. It's like you need to build this up from the ground up. What characteristics of the problem lend itself to using X, Y, Z, or whatever you want to do. Anything you want to do, there needs to be some kind of justification for it, some kind of reasoning that the interviewer can follow. Otherwise, you're just going to be skipping steps, which was exactly what happened here, again, with the definition, the height of the left subtree and right subtree. So, overall, this is your homework. What I want you to work on, I don't care if you don't get to dynamic programming. Personally, I would think that is secondary to this, because if you can't solve this kind of problem or without explaining things, then you're going to fail a majority of the problems. But if you can't do a dynamic programming problem, then it's just like, well, okay, it's dynamic programming, and it's less likely that you'll run into it. Because there are times when people have run into interviews that they don't ask dynamic programming, and you can ask Jason, see if he got one. But yeah, I would say just work on the issues that are going to give you the most value, that are going to affect the most of the problems. And I can tell you that recursion pops up a lot. And just in general, being able to draw out the stack trace and what you want to do is going to be immensely helpful. So that's my feedback to you. Do you have any questions?
For drawing out the stack trace, do you do that in non-recursive problems too, or is that more just like a step-by-step kind of thing?
I still do it as step-by-step or recursive. I just say what each of my values are at each iteration. Because very often when we iterate through like a linked list, I still want to be able to say what my values are and just to double check to make sure that everything works. Of course, like what you did today for a stack trace and drawing out what the values of each variable are, I just do it much faster. That's it. That's the only difference. And plus, like, doing this also helps you understand what you need out of each function call, what you need from each step. And it's just an overall good exercise. You just need to be able to do it. Now, when it comes to the actual interview, you may not necessarily do it, but I still think this is a very good exercise, because at least you will train to at least look for what you need to come game day. Does that make sense?
Yes.
So, any other questions?
No, just feeling extremely frustrated and demoralized, but hopefully after some more practice I feel better.
Yeah. I mean, it's natural, you know, because you're running into these mistakes, you're running into these issues. It's natural to feel frustrated. But yeah, but that's why you're here. You're here to hopefully fix those issues, and then hopefully next time around you do much better, and you can have a very clean, very easy solution.
That's the hope.
Yeah, did you feel that everything we talked about today was helpful and useful? Because I know that I was being harsh on you, but I'm trying to really get you to see that you are skipping a lot of steps.
No, I mean you're fine. Don't worry about how harsh you are. Honestly, it's better than trying to coddle someone. Yeah, I this didn't go where I thought it was going to, but I'm also glad it did because it kind of showed a horrible flaw that needs to be fixed.
Yeah, but that's why I'm here, man. So yeah, good luck with that. Hopefully everything works out, and let's talk again next week. Keep me updated on how things are going, or if you have any questions.
Sounds good.
All right, yeah, take a breather for the rest of the night if you have to.
Yeah, I think I need to take a couple hours.
Yeah, for sure. Take care, man.
See ya. Thanks.
Yeah. All right. So, yeah, that was definitely a lot more harsher than I expected to be, but I think he got a lot of value out of that. I think he understood what he needed to do. So, you know, I think I did my job. So, with that, I'll answer some questions that you guys have. So, I think he's doing a DFS find all unique paths approach, find minimum max depth, take the diff. Yeah, that's one option. You can walk through it in the first pass, and then in order to get the heights of each node, and then in the second pass do the operation. But again, that is the non-optimal answer. And I would fully expect from an L3 interview to be someone to be able to at least derive that answer and recognize, hey, yeah, this was a suboptimal solution. Be able to recognize you're doing two things in two steps. How you do in one step? Well, okay, return back the height at each step and then do the operation. There's a different approach where you can return 0 since there's no height. I think that's what he's doing compared to left and right heights. I already addressed that. He's having trouble finding the height if you're returning just a boolean because he's thinking he needs to build up height. Yeah, exactly. Because the fundamental question is if it's height balanced. It's not what the height is. What the height is just one part of the component. It's just one part of the answer. So if we go back to the definition, that's just one part of the answer. Overall, all three of these conditions need to be satisfied. So the answer is actually a Boolean value, and that's what I'm trying to drill here. You know, I'm trying to make sure that he understands that he needs to be able to look at the root problem of what he's working on. So I'm glad you like my approach. You know, I get sometimes people who rage quit on me because of this, because like me, you know, trying to work them. But you know, I'm glad you guys appreciate it. What's the goal? What is the goal? 2 recursive passes on this. One is find true, false, and one to return the height tree. I mean, again, you could do it like that. So I think they're doing both in one pass. Can we use CoderPad? Again, you're gonna be getting a lot of Google Docs. Seriously, like Dropbox is gonna do Google Docs. No one wants to pay for CoderPad. Like, let's go to CoderPad. It's good. Don't get me wrong. But like, let's see how much it costs. You know, pricing. You know, for a personal file, $50 a month, 5 interviews. Holy shit. Okay, and then team-wise, so it's like you start at enterprise value, like $1,500 a month. $1,500 a month times 12, what? That's $18,000 a year. You're talking about $18,000 a year on CoderPad when you can talk about doing for free on Google Docs. So, oh yeah, and even the personal one only gives you 5 interviews. What? $15 interviews for over. Oh my, yeah. So if I went with a personal license, I'd be paying $50 a month to do 5 interviews a month, and then I have to pay $15 just to do more interviews on top of that. Now, any business is gonna be like, holy fucking shit. There's no way I'm gonna do this. It's just what makes way too much money. Like they're doing mock Google. Yep. Has some Google Docs. They've never rage quit on coaching stream, but they've rage quit some sessions. I post a solution that I think works on Discord. Kind of makes sense. 3. Oh, it doesn't early terminate. I mean, yeah. Like the early termination is really helpful. It doesn't change your time space complexity fundamentally, but it's a great way to skip over a lot of early work that you don't need to do. What about time space complexities? Well, I'll leave that as an exercise to you, but essentially, are you really using any additional space? You know, again, if you did the 2 pass, of course you're using additional space. But then if you're doing it for just a 1 pass, how much additional space are you really using? I mean, you know what? Fuck, I'll just tell you. So the runtime complexity is basically order n, because where n is the number of nodes, because essentially you're evaluating each and every single node with some optimizations of whether or not the left subtree and right subtree is height balanced. So it's going to be less than n for sure. And then space is like order 1, because each time you return, it's going to be the constant. It's going to be the same amount of space. I mean, you can argue for like, oh, if it doesn't get garbage collected, but then at that point, it's just on you, or not triggering the garbage collection, or if you're writing in C++, not deallocating. So, yeah, people have rage quit. So, I mean, it shit happens though. But hopefully, you guys enjoyed the session. Hopefully, you bleh. Okay, it's been 3 hours. God, I'm not used to doing these long streams. Usually, I'm just used to coaching for 2 hours. And then that's it. But yeah, 3 hours might be a little bit long for me. So hopefully you guys enjoyed that. I'll give it another 5 minutes before I turn off the stream. You guys can ask whatever questions you want. Oh, the evaluation. Basically, if someone came to me with this and, you know, it was just straight up, like even the beginning one, the first question, I'd be like 50-50 on an L3. You know, the reason why is because if we look back at, oh man, Doob has been playing in the background. God damn. Let me pull up the thing again. So if we go back to his original, let me remove. Yeah, let's go back to the original. So first things first is the height tree. I kind of had to help him out with organizing his own work. And then he kind of messed up here. Remember, he got really ruined here because of his ceiling. I mean, he got the most, like 99% of the answer right, but then he messed up here. Now, usually I would forgive it, except that he just kind of like patched and prayed it. So it's like, no. That's why it's like 50-50 for me. On a good day, I might be forgiving. No, on a good day, I probably still wouldn't be forgiving, to be honest. Because, yeah, the reason why is because it's just the fact that he randomly slapped this in there without any justification. If he put it in there with some justification and couldn't see like his mistake, then fine, whatever. I might be nice. But the fact is that he just slapped it in because, like, oh yeah, I just ran to a situation where that was needed, but then he didn't weigh it out against all the other shit that he needed to do. And so that's pretty much the reason why that this ended up, I would say, not really passing. So honestly, on a normal day, I probably would just fail him. I'm just gonna be honest, guys. I am a really harsh grader. You really don't want me to be your interviewer, but that's why like I really don't do a whole lot of interviews for companies. I mean, I do some, but it's like my standards are really, really freaking high. Like you basically would need to have, if you don't get the right answer, you need to have the right logic. At least when it comes to me, you have the right logic, is reasonable, everything makes sense, and you still get the wrong answer. Fine, I'm okay with that. But 99 times out of 100, you have the right logic, you will be able to get the right answer. These problems are not giga complicated. Like these code is like fucking 10 lines. You know, like how hard is it to come up with like bulletproof 10-line code? Okay. What do the people say when they rage quit? That you're being too harsh or that they haven't done enough leak code? I don't know. They just come up with some random shitty excuse, you know? They're just like, oh, you're just being too mean. I think you're just yelling at me because you enjoy it or whatever. Like, no, not really. I don't enjoy yelling at people. You know, I enjoy seeing people like actually succeed. And to my knowledge, this is the thing. This is what, you know, breaks their bad habits, that I can show them what exactly they're doing wrong and, you know, really get it into their head. Because, you know, the way I see it, there's two components to it. The first one is that I put out what your problem is. The second one is for you to actually get it and drill it in your head. And, you know, like, it's like someone says, oh, you broke a plate. You know, you actually, or you spilled some water on the table. You know, most people just say, oh, that's not a bad deal. You know, it's like, but let's say you spilled, like hydraulic, like, what's a good example? Let's say you spilled like phosphorus acid or some shit on the floor, and I'm just gonna, if I say it like that, hey, you spilled some acid, You know, you're not gonna get it. You're gonna say, "Oh, it's just a mistake," and you move on with your life. But if I start being harsh on you and I really start breaking down your mentality and start saying, "Hey, this is what you're doing wrong. Focus on this. This is what you're doing wrong. This is wrong." You start really getting it. And this is the way I know how to do things because, you know, I'm harsh on myself. Anyone who is successful at these things are harsh on themselves. And, you know, it's just, it's how people get it. That's one reason why I think I'm very effective. It's like, I can point out the mistakes, but people are if I'm nice about it, people are just going to walk away and just keep doing whatever the fuck they want to do, you know? But if I actually, you know, drill into them, then they actually start working on it. And if I can get them to change one or two things from a coaching session, I've done my job as a coach. You know, there's only so much I can do in 2 hours, but my job is to get them to succeed as much as humanly possible. And if I can break some habits that are causing them to not to, then, you know, that again, that's the whole point. That's the whole job. Actually, could you glance at the Discord solution I posted? I think it's optimal as a tuple returning approach since it's a single pass. All right, let's take a look at it. Notice me. Wait, did you posted on Discord, right? It's I see some shit about Quakes. Wait, Tendies, is this you? Wait, Ricky, you gotta tag me in it. Sorry, I don't see it. Have you done any real interviews for Uber recently? If so, what were they like and different compared to this? I mean, the only difference is that I'm not gonna yell at the guy. I'm just gonna be like, okay, why'd you do this? Why'd you do this? And if he doesn't give me a satisfactory answer, then it's just like, whatever, you know. All right, let's see what Tendies came up with. Balanced helper, if not cur, self height, min, max self height. Else helper, cur left, cur right, helper root 0. If it's yeah, let's see. No, I don't think it handles the skinny case. This case where it is like really, really long on the left and really, really long on the right. If not cur. Oh yeah, okay. If not cur, then you're saying if it's null. If it's null, then you're saying the minimum height to be the whatever the minimum is, or the height it's currently at, or the max height. I don't know. I'd have to run this. Maybe does it work? Wait, no. Because if cur is null, then you're saying the height to be 1. I think that's wrong. Well, then again, everything's bumped up by... Yeah, I think that's wrong. Because if the height is null... If the node is null, then the height is going to be 1. And that's incorrect. I don't think that's right. Sorry, Tendies is... I just spent too much time on Wall Street Bets. Have you done any real interview? Yeah. I'm just basically saying that I basically give similarly difficult problems, if not a little bit harder, depending on who I'm interviewing. You remind me of Jewish mother. Nah, man, I ain't never had a no Jewish mama. I hope you make a Rage Quit compilation. Okay, dude. If they Rage Quit on stream, I will meme the shit out of it. I guarantee you. You mentioned dynamic programming is not likely. Which topics are and which topics are? Any list of topics patterns recommend? Study all of them, dude. Like, to be honest, like 9 times out of 10, what you're going to be doing is like, there's no point in gaming the interview. I said this like before. Like, it doesn't matter what question you are presented with on game day. You should be in a position where you can answer all of them flawlessly. Dynamic programming is just least likely to show up. So when I say to not really focus on dynamic programming and to focus on all the other shit, that means that I am saying you have a certain amount of time left. Allocate whatever time you have to focusing on the things that will get you the most gains. If you had an infinite amount of time, I would still tell you to be able to focus on everything and make sure you master everything. Psychology, yep. Post on code block called Tendies. Do I ask doc points off for a candidate? They ask for tips. Yeah, most like 9 times out of 10 I do. It's like, oh, can you give me a hint? Obviously, that's like really big. Maybe 1 hint, maybe I'm okay. But even then, that would disqualify you from getting a perfect score from me. At most, if I gave you a hint, you would be borderline. But yeah, you should not be able to ask for tips. You should be able to present your argument, say whether or not it's correct or not, and be able to make the case for it. Or like, you know, if you miss out a case, fine. I'm gonna just probably tell you what that case is, and then I expect you to run with it. So that's not that's basically how I would play things. See, what I expect when it comes to the workplace, I expect people to be fully competent and to be able to break down and present a logical argument for what the hell they're doing. You know, I expect people to know what the fuck they're talking about. And the fact of the matter is that when it comes to coding interviews, you guys who are doing the coding interview should be way more prepared than I am. You know, I'll know the solution to the problem and I'll understand the logic to get there. But then it's up to you to make the argument for what you're doing. You should know all the pieces cold, and you might come up with some crazy ass solution that I've never heard of and come up with some really cool justification for it. But it's like expecting me to like feed you the answer when you should be the one making the case for the answer is not good. Not good at all. Yeah, don't really ask for tips unless you absolutely need it. Like, there's no other way of saving your interview life. You either get the tip or you fail it. That is the point when you go ask for the tip. So, hold up. Yeah, might as well let's put Dota on in the background while I'm answering the questions. So, God, get some water. Oh shit, he's lagging. Alright. So. Meteor Hammer on Void? Is that a thing? What? He's not the carry, is he? Is he offlaner? 12 CS? No, he's a support. The heck? Alright. I look tired. I mean, yeah, it's been long days at work, man. Is Leak Code interview cards good? I've never actually looked too much at the curated list. I mean, it used to be free. I don't know why Leak Code decided to just like suddenly make them paid. But you know, if you are studying, $35 is a small price to pay, to be honest. Who is this streamer? It's Dubu. When you give interviews, do you suggest breaking test cases when you see bugs? Or do you say you got a bug and let them find it? I always say you got a bug. I expect them to fully understand how to test their own code. And if they understand their algorithm very well, they can usually think of it in like after 1 or 2 passes. Usually it doesn't cost them more than 2-3 minutes of the interview to do it. And even then, like if you miss a test case and then you correct it later, I'm like, chill. It's fine. I have internship starting in summer. Should I put incoming ex-intern on the resume and apply to fall internships with that resume? Yeah. I mean, you could. I don't necessarily knock that, but again, that's like kind of irrelevant to me because if you're incoming to an internship, then it's like, you haven't done any work yet. So, why the hell should I care? I'm not going to ask you any questions about your incoming internship. Like, there's nothing for me to ask because I don't know what kind of developer you are because you haven't done any work on that. So I don't care. If someone wore a Leak Code t-shirt to an interview, what would be your first thought about them? Pay to win? No, everyone pays in some regard, to study and get good at coding interviews. It's just like whether or not you pay it with your time or money. So if someone came in with Leak Code shirt, I'm just literally like, I get it. Probably I'd do a small laugh, but I wouldn't think too much of it. So, All right, I think that's it for the questions. I should go eat dinner. Thanks everyone who stuck around on the stream, who watched that session, and hopefully you guys got a lot of value out of it. Hope I'll do one next week. Hopefully, we get another success story that people can talk about. And yeah, if you guys have any feedback for me, just let me know in the comment section or send me a message on Discord or shoot me an email, whatever you want to do. And I hope to see you guys around. So take care, y'all.